Hello, everyone. Am I audible? Okay. Let me turn off desktop audio for a second. Okay. So, what are we going to do today? I was thinking of continuing the Bloodbound game that we have been working with, so far. And last stream, it was a pretty big waste of time. I was trying to calculate the tile size so that I can make a grid of tiles and then continue on the platformer because um, off stream I had um, explained last stream I explained what I did with OpenGL and how I set up the major stuff that we were working on. So where were we? Okay, let's just see how far we've gotten. Wow, C++ making takes some time, and okay. So yeah, we left off here and we had to calculate the tile size. So my solution for that was to do whatever this is. Okay. Um yeah. So here we had set the orthogonal matrix, orthogonal projection matrix, yes, from negative aspect ratio to aspect ratio, -1 at the top to 1 at the bottom. And so I wanted to turn those coordinates into pixel coordinates first. So to turn them into pixel coordinates, I decided to look at what the orthogonal matrix actually looks like so that I can take out the scale from that, how it scales the vertices that we have here. So here we have a list of 0.5, right? So it's half this, it takes up, one tile takes up half the screen. But after it goes through our vertex shader, it multiplies that vector coordinate by our model matrix, and then by our view matrix, and then by our projection matrix. Our model matrix allows us to move it locally. So if we wanted to rotate it or we wanted to just set a scale, we could do that, but we don't want to change that. Then we have the view, which is basically the camera. We don't want to change that either right now. And so then we have the projection, which is the only thing that's being multiplied here. So to get the orthogonal matrix, here, let me bring up an image of that. Orthogonal projection matrix. Here. So we have 2 upon right minus left, 2 upon right minus bottom, and -2 farm. Let me actually, I forgot to pop out Twitch chat and everything. So let me just do that real quick. Uh, Chat settings. Mm-mm-mm-mm-mm. Pop out chat. Let me bring that here. And then let me also bring out my camera. Let me bring out my camera's window projector source. Yep. Let me set that at the corner so we can, there we go. But we wanted to pin both of those, so let me pin this, then let me pin this too. So just like this, I'm gonna pin this too. Okay. Right. So let me, yeah. So here, when we multiply our vector with this matrix, what ends up happening is it translates by whatever is on the rightmost column, and it scales by what's in the diagonal right over here. But since we don't care about z, because things that are further away and closer to us look the same size because there's an orthogonal projection matrix, all we care about really is just the x and y, and or just the width and height. But since if we take our height is from -1 to 1. If you just add those together, that just becomes 1. All right, 2 upon top, which is, let's see, what's top? Let me turn on egot so I can get auto completion here. Come on, yes. So we have bottom then top. So that's -1 at the bottom and 1 at the top. So 1 minus minus -1, so that's 1 plus 1, that's 2. So 2 upon 2, that's 1. So it just scales by 1, which leaves us right where we started off. But it does scale on the x, and by what amount? This is 2 upon negative aspect ratio plus aspect ratio. Sorry, yeah, basically. So I just put that into my scale right here. And so I was about to play with it, but I ended my last stream. So here we're going to figure out if my scale actually works. Let's see. So we have my scale, which is a specific number. And now what we want to figure out is, so our model mat is translating our thing. That's all right. I think if it translates everything by the same amount, the scale shouldn't change. Let me bring that out outside my loop, just where I'm about to create my tiles. And then let's see if my tile size, so this tile size is wrong apparently. Let's do a my scale divided by 2, my scale divided by 2, and then let's do a my scale, my scale. So these should be diagonally. They should just touch, their tip should just touch. Okay, so one was created here and the other is nowhere to be found. Let's block out one of these and let's see where we ended up. Sorry for that. Let me make and then slash it out. Okay, so that was this line. Then let's just put it at my scale, my scale. Am I tweaking? Oh, okay. So it's trying to. Oh my god. You know what's happening? What's happening is if we take the initial coordinates and we turn them into pixels, that will be okay too. But if we turn them into like tile coordinates, ugh, kind of disgusting, low key. So here we should just be able to. Okay, I think I know what to do. So we can do a float tile size, and we can turn that off here, right? And then we can take this our scale, put this here, and then we can set our tile size to be equivalent to whatever, right? So our tile size will equal my scale multiplied by the window's width. My scale was not defined. What is bro on about? Oh. So yeah, instead of my scale now, we have tile size. However, it wouldn't have been defined up till now, so I'm going to have to do just put them both outside again. Epic programmer moment. Repeat. Okay, do not copy the second line. That's fine. That's fine, guys. We're going to take my scale and multiply it by our window's width. Come on, you can do it. There we go. Let's see if that works. Please work. Just a second. Okay. Sorry about that. So apparently our tile size is absolutely humongous. That does not look like the correct tile size. Let's multiply that by the height, or maybe the aspect ratio. That sounds correct. but I know it's not. What about the aspect ratio? That that exactly at the center. So if I say tile size times 2, will that just work? So weird. Is there any other tile other than this? No, then what? Okay, this makes absolutely zero sense, but if I take Windows width, and then I have my tile size now, right? Because this is how much it scales normally, but we're multiplying our window width by that. Why are we doing this? So unless we take out all of these, unless we take this out completely, oh, because I'm doing that file size, but it initially plays that there. Ah, okay, let me move this outside. Let me move this outside. Move all of this outside. Here we have our view mat. Can't really do much. Projection matrix should really be the same. Let me just take that out and put it here. Oh, but our model mat can't really go outside because it's dependent on wherever the tile is. Just our projection matrix that can be taken out. So all we have to really do is to just take both of these, put them here. So what we're going to do here is after we've set the projection matrix, we're going to take our scale. Why is this gotta be so complicated? We have how much it scales. But if we just directly take the height, if we just directly take the height, wouldn't that be the same thing? If it does not scale on the height, then it's 0.5 of our Windows height. You see, what the hell is this? File size, nowhere. My scale, nowhere. Okay, think about this just once more. Here, we have our window and we have this stretched out cube. What happens is when we apply the orthogonal matrix, when we apply the projection matrix, it squishes this down by a factor of ms. I'm just going to call that my scale. So my scale, it just does that. Once it does that, it does not affect the height. Note that it does not affect the height, which means we just take the height of this. Now, what is the height of this? It's the height of our window times 0.5. That should be it then. So what it does is I think it's translating too much. Let's give it pixels. Let's give it solid pixels. So if I give it 0, if I give it 0 here, it should be at the top left corner. Okay, it centers at the top left corner. Now Let's make that. Let's add the negative aspect ratio, right? Let's not do that. So now what? It's in the center of the screen. Okay, we add the negative aspect ratio. We times it by 2, then we do 1 minus. So at the end of the day, we have to like plus. Okay, what's this? Tile.getPosition.x. We take its x, assume it's in pixels, divided by the window's width. It's from 0 to window's width. Then we take the left, and then what we're doing here is we're dividing by window's width, then multiplying by 2 times the aspect ratio. So here we have this entire thing. No, what? What's going on here? We're dividing by our window's width. Oh, so we have it from 0 to 1. Then we're multiplying it by our 2 times aspect ratio. So now it's from 0 to 2 times aspect ratio. Then we do negative aspect ratio, which means negative aspect ratio to positive aspect ratio. No, negative aspect ratio to 1. No, negative aspect ratio to 2 times aspect ratio. No, that's still not true. This is negative aspect ratio to aspect ratio. So we have negative aspect ratio to aspect ratio. And so once we have our orthogonal matrix here, that's going to be fine with that. Which means if I say Windows width and Windows height, that should be cool. Okay. It's almost doing it. Doing some weird stuff too, but it's almost there. So let me think about this. We have y, which means we get the calculation of y, and then we divide it by our Windows height, then times it by 2. Then why are we doing 1 minus that? Like, why are we starting at 1 and then doing all that? Can we minus 1? Because at height, up top, so our bottom is -1, our top is 1. So we add 1, then we subtract that. So that should work. Maybe it's on the Z then. That's all I can think of. That doesn't make any sense. That does not make any sense. Sense. That does not make any sense. Okay, you know what? Let me sort of cheat, get tile size. So in landscape mode, you'll have whatever this is. 0 for times 3 units y, 2 units high. In portrait, it is now this. No. Tile rendering most efficient way. There's something else. Okay. The UV coordinates can be calculated in the shader because this vertex shader doesn't know which corner of the quad it is processing. Now your shader knows what corner this is, this vertex. Okay. Yes, that's why it's called a memory performance trade-off, whatever. You defined a full screen quad in screen coordinates. This brings it back to 3D. Then you do the homogeneous, then you don't exactly know how far the plane your tiles are on is from the camera, so we do a ray plane intersect. What? Get house texture ID, calculate UV within the texture on your layout for. What? The factor 0.0625 is if you have 16 texture next to the from left to right on your add list. Files I need a bitmap, then render grid with uniform for scale and origin and your tile ID texture. I wrote this once for hex maps and guard rendering 4K by 4K tile maps with Hurt. Filtering the tile image is a bit tricky though. So you're saying I just calculated manually within that and just remove the orthogonal projection matrix altogether? That's kind of goofy. So if we just completely remove the U projection matrix, and so what are we going to do then? What are we going to do then? So we have whatever this is. You know what? Let's just comment this out. Let's see what this gets us. Nowhere, obviously. It needs it from 0 to 1, but we can pass our width and height in as a uniform. That's basically doing the same thing. Our projection matrix is literally just multiplying it by that. All it's doing is it's just cutting down on the height and just translating it a bit. It's translating it a bit. This part, it's translating it a bit. So right plus left upon right minus left. So right plus left, that's 0. Then top plus bottom, that's also 0. Far plus near. Okay, we don't care about that. And it's 1. So it isn't. Why is it different? We have a my scale equal to 2 upon that side. We don't technically even need it. Okay, let's just see what happens. We have 0 0. Put that in our tiles. Let's not even translate this. Forget translating this. This should be in the center of the screen. Okay, and it's doing all that, right? The problem here is, oh, it should calculate that every time. Should be calculating that every time. Our projection matrix needs to be calculated every time because our window size changes, so that it should reflect that in our projection matrix, because that depends on our current aspect ratio. Here we have whatever this is. Now you see how it's changing. Either you lock the aspect ratio, because what's going to happen is it's going to show much more. Because the bigger the window, the bigger the size it is. It's exactly doing let's put it here. It's not even taking half the screen. What is it doing? Okay, it's taking half the screen. This is definitely half the screen. So you know what I'm gonna do? I'm gonna put it from 0. I'm going to put x, y. So the y can go from 0 wherever there's 0.5, and then OpenGL chords. Here we have OpenGL chords, and Okay, it's doing things, doing whatever it wants. You see, with this an ortho, oh my god, with an orthogonal projection matrix like this, you can just directly use pixels, but this doesn't work. That's the entire problem. This doesn't work. But even if it doesn't, we have negative. So here we have, okay, this. So 0.5. It will be flipped on your screen, but we take 0.5, 0.5 from the bottom left, right? So it's from the bottom left on your screen here. Yeah. And then 0.5, 0.5. Oh, this is top right. Okay, I should have just read that. 0.5, 0.5, negative point. Oh, so 0 is in the center of the screen. 0 is in the center of the screen, which means it's going from negative 0.5 to positive 0.5. If we went from 0, no, if we went from negative 1 to 1, so if we went from 1.0, 1.0 to negative 1.0, 1.0, or 1.0, 1.0, one 1.0 and 1.0. Okay, let's see. That should be just so. Okay, no, maybe Control X space. Then wherever you find a 1.0 here, I'm gonna place that with a 0.9. Bruh. Okay, here we're gonna replace 1.0 with 9, and let's see if that has made any difference. Okay, apparently just 1.0 is confusing for it, but it takes up 90% of the screen. It just takes up 90% of the screen. That sounds cool. So this should take up half the screen. This should always take up half the screen in terms of height, right? Whatever you do, look at that, look at that. Whenever we scale the height, if we scale the width, nothing changes. Scale the height, that's always half the height. So at the end of the day, whatever our height is, the tile size must keep changing. The tile size needs to keep changing. But instead, we're going to have to change the model matrix. Negative aspect ratio plus tile get position X. We take that from negative aspect ratio, positive aspect ratio. We have 1 here. Now, if we want to calculate the tile size, since we did not even scale it, all we did is just translate it from 0 to Windows width. Okay, I think I understand now. So if I do 0, 0, this will be, its center will be in the top left corner. Okay. Then what's going to happen is the tile size is going to keep changing. That's the difference. This is why we want a relative thing. We don't want it from, let's just keep it from 0 to 1. Instead of this, let's just keep it from 0 to 1. So let's not divide it by Windows width. Keep it from 0 to 1. This is all also from 0 to 1. And so I'm gonna say that here. So tile position is from 0 to 1. And then, now here, okay, and then if I say my scale, that is wrong, but it's something. So if I say 0, 0 now, it's still going to be at the top left, but 1, 1 is going to place it at the top right. Sorry, bottom right. And let's see that. See that in action. Okay, it's there. There. It's in the top, bottom right. Now, if this was half of whatever that was, our tile size needs to keep changing. I don't want to keep 0 to 1's all that. Then my scale should be... Okay, let's put my scale on the X only. And then let's put it on the Y only. So what the hell is that, right? Then let's put my scale here. It's just a weird thing. Yeah, why would... Oh my god, why would that happen? If we are at 0.5 and 0.5, put it in the center of the screen. And now I want to keep changing the tile size. So what the problem is, it's not a constant. The tile size keeps changing. But if we create it based on the tile size, you see the problem. So we're gonna have to move all of our tiles or just create them once in the rendering. Dumb as hell. So our tile size is never just a single constant. It changes with respect to that. But if this is always 0 to 1, then this must also be some specific thing. If we're looking at the height, this should be like 0.5. So let's just do one thing. Let's just make this 0.5 and this 0. What? Oh, okay. I put it on my scale. 0.5. Okay. Now let's put this at... This is 0.5. We're going to put this at 0.5. Of the height. So let's just try height for once. So if we have 0.5, if you have 0 here and 0.5 here, this should be right on top. Okay. Okay. That is exactly what we want. But that can work on columns. That just won't work on columns. Unless we maintain an aspect ratio or we just make the game cool where we've not locked the aspect ratio. That's going to keep changing. And I think all of this because we just let the aspect ratio run free. Okay. So if we just paste this here. We're doing all the window hints. So, okay. We want to do that after. Let's See if that works. 16:9. That did not enforce it at all. Maybe if we put it here. And you know what we can just do? We can say, acha, Windows height pe rakho. I mean, put it on the Windows, keep it at Windows height. And then the width will just be that multiplied by 16. Okay, multiplied by 16 divided by 9. And that's just going to be our Windows height. See if that works. I think it should be the opposite. Yeah, it should be the opposite. It's supposed to be 9 upon 16. I'm just going to say 1 upon aspect ratio. Aspect ratio. And the aspect ratio, no. Not really what I was saying. Okay, it did a thing. We can resize it, but our Windows height is multiplied by our aspect ratio on our width. It's bigger than the window, that means. Yeah, because if the tile size kept changing, that would be a problem. And I don't want problems. Lock the aspect ratio. Its current ratio, use its current size as the ratio. Disable the aspect ratio limit for window. Set both terms to don't care. Window size limit. The aspect ratio of a content area of a window mode can be enforced with. So it's not being enforced though. Why is that not working? It's doing whatever it wants. Not really listening. Try that again. Working. Okay. Let's just do the opposite. Multiplied by 16/9. Because the aspect ratio, have I set the aspect ratio? Aspect ratio is here. Oh, we haven't set the aspect ratio. It just calculates it in real time. We don't want that. We only want a 16:9. A 9/16. What is happening? Oh, look at that. It's cut off. Cut off from here. And it's trying to calculate that on this aspect ratio, but we can just locally comment that out. 16/9. Uh, ooh. But if we static cast float to win height, where? Ortho needs an int for the aspect ratio? Oh, okay, my bad. Still not doing what I wanted to do. Gotta be so complicated. We take our width, set it equal to that. Then we're like, okay, our height is just if we multiply that by 16 and divide it by 9. Dividing it by 16, dividing it by 9? Dividing it by 9 upon 16? Divide by 0? So let's just divide it by aspect ratio. Oh my god. I closed the terminal. Let me open it up again. Yep. Make nn dot slash a dot out. Please run, please run, please run. Why do I keep closing everything? Okay. We're dividing it by 1 upon aspect ratio this time, please. Please, 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 please. Not even here. Not even here, bro. It's not even here. What's the point? What's the point? What's the point? Okay, let's just leave it up to there and then make it think that it should be still 16 by 9. Yeah, whatever. Whatever. We can't lock it right now, but this is how it should be. Which means, you know what that means? I have the aspect ratio ready. The aspect ratio ready. All I have to do get file size is moment of truth. Okay. Because it won't change on its height. But if I use my scale, which is this quite, not quite. Maybe if I use aspect ratio. No. Maybe if I use my scale, right? My scale times what we were actually trying to scale, 0.5. My scale plus? No. Yes! My scale was the scale, and then what we were trying to multiply it by. Oh my god. God. Bruh, that killed me. That killed me. That killed me. That killed me. I finally figured it out. My scale, we're just gonna take what we're scaling by, then we're gonna multiply it by 0.5, and then take y, keep y at 0.5. And this was the exact same concept. We didn't even need to lock in the aspect ratio. I don't think we need to lock the aspect ratio anymore. If we do this, however, the problem with this is the tile size keeps changing. So if the aspect ratio changes, the tile size also needs to change, which means whenever we resize, we're going to have to recreate every tile, and that's going to be really expensive. I don't really want to do that. That's why I'm keeping it at a 16 by 9. Finally, that took way too long. That took way too much time. That took absolutely way too much time. Let's see, auto. Okay. We don't care about pose. Tile position is from 0 to 1. That's true. Projection matrix, we don't need to recreate anymore because our aspect ratio is locked. Let's keep that outside. Keep that outside. And our model mat can also stay the same. Right? Everything can stay the same. Actually, yeah. Since our aspect ratio doesn't change, yeah, tile's position doesn't change. But we're rendering that every time. So I'm allow that. So here we are model mat scaling by some constant value. Now this is the problem. If we scale it by something, it's also going to have to, I don't know. Let's see. So first of all, let's run it without scaling. Okay. And now this exact same scale should continue onward. So if I scale it by 0.2, that should produce, yeah, it doesn't really reflect that. What we're instead going to have to do is in my scale, we're also going to have to multiply by 0.2. Yeah, and that works on the width, and then on the height too, 0.2 if I do that. Yeah, which means I finally figured it out. We're gonna keep the tile scale to 0.25, and then wherever we use 0.2, we're gonna use tile scale. Here, same thing, tile scale. Not there, right here, tile scale, and that's cool. Here, we're going to name this, instead of my scale, we're gonna name this tile width. Technically, this is a const expert. Yeah, this is a const expert. So we're gonna have tile width, and so we can just hash define that. Then we also have a tile size, but this tile size is, yeah, this tile size is useless. Nobody cares about this. Actually, so we're gonna use tile width here, and I'm gonna put that up top. Tile scale, define tile width to be all of that. Invalid type argument. Oh, we'll put a semicolon at the end. And that's not true. What's happening? Oh, equal sign. Okay. Okay, that's pretty cool. Let me resize the window just to see. Look at that. Make it 0.5. That's cool. 0.3 maybe. There we go. So we have finally figured that out. Now, when we're actually creating our tiles, what we do on the X is tile width times 0.5 and then tile scale times 0.5. Why has it got to be 0.5? That's like yeah, that's got to be added to both tile width and tile scale. So tile scale times 0.5, and okay, so I'm not gonna put it to, yeah, it is tile scale though. It's tile scale. It's not, okay, which means this, that worked. Our tile scale didn't. Okay. Basically, I think it's let's remove what we did right now. Okay. Okay. So tile scale must be multiplied by 0.5, and tile width must be multiplied by 0.5. Tile scale multiplied by 0.5, and that multiplied by 0.5. But that's not the tile scale. So define tile height is our tile scale multiplied by 0.5f. That should do it. Not really. Take our tile scale, we multiply it by our 0.5, and then we take our tile width and we multiply it by 0.5. Oh, because we didn't tile height. Thank God. We can resize this and it's going to stay the same. That took quite a lot of time. Finally figured out platformers. I figured out platformers now. How long did that take? That took an hour. Okay, no problem. But now we have our tile width and our tile height, and we can easily move forward by making a grid of tile widths and tile height based on our level. Okay, let me think about this. Since everything is a constant here, none of that changes. None of that changes. None of anything changes, but we just move through tiles and then render them according to their position. So here, let's just create some tiles. Um, we're going to have to add like an enum of tiles. So let's just see what the best type of enums is here. So here we're doing this. Here we take enum color and then do this. You don't have to be named, but unnamed enumeration should be avoided in modern C++. Starting with a capital letter, enumerator starting with a lowercase letter. Okay. And then we have all this. Then we have cardinal directions. Yeah, we just keep trying different types. So, but these enums don't have a type. Can you set specific type? These must be a map. Like, it's probably supposed to be a map. C++ map. Stood map. Yeah, you see the age map? Is an associative container that stores elements form, blah, blah, blah. And we can insert it. And insert a pair. So maps have a pair. That's fine. Takes both of the types. So I think we're going to have a we're going to have an enum of file type, and there's going to be grass for now, and grass and stone. That's the two types, grass and stone, and then we're going to tab these out, and we're going to create a map. So I don't think this should be global, but let's just keep it global for now. We're going to change it later. We have our tile type. We could also make this static and then put it in the class, like here, you know. So this takes a tile type and it returns a, what does it return? So this should be a const expr. The static, we have an included vector. We're going to include vector, and so for every tile type, it takes in a tile path. So tile path. Which would be a std string. It's not going to be a std string view, so we don't even have to take that. We can just take the tile type, and we can call this the type, and then we can call this the type. but the entity shouldn't have to take that. So what we're going to do is this is a type texture type type text path. Yeah, a tile type text path. That seems way too long. M text. What's the age map? So text map. Is that okay if I say text map, like I'm mapping the tile type? I think that's pretty cool. So we can do this. Can the tile type be enums inside C++ classes? Learn CUP.com. Scoped enumerations. Although unscoped enumerations are distinct types, they're not type safe, and in some cases will allow you to do things that don't make sense. Consider the following case. Consider the following case. So here we have when color and fruit are compared, the compiler will look to see if it knows how to compare. Yeah, well, compiler will compare color and fruit as integers and find they're equal. Yeah, that doesn't make any sense. The scoped enumerations is where you do the enum class, which defines it as scoped rather than unscoped. Now this is what we wanted instead. We wanted an enum class. Let's see if that can be equivalent to anything else, so we don't have to create a separate map. I don't think it works. Yeah, so we don't really have to do that, but instead we can have an m type, and so we can just initialize that here. So we can say our m type is just our type, right? And our m type is a tile type. Yeah. Should I just say tiles, or tile type is tile type dot grass? Like, so our tiles. Since all this plural, class enum class named tile type. Directions. Yeah, low key is not that. I think it's fine. Tile type. So we're going to take an mtext type from tile type to our string, and first is our grass. So these are pairs. So we're going to say tile type dot grass. That didn't work because it's expecting an identifier. No. Maybe it's not. Give me some examples. I need examples. Give me some examples. So here we're doing string to an int, and we have this, and we can just directly do the thing. Oh, wow. Okay. Best viewers on. No. Please do not do this. Let's see. Do I have to pop it back out? Wow, it's a throwaway account. Invite whisper report. That sounds like a promotion. Manage suspicious user. Okay. Anyways, so here we have a map, and we're going to, instead of our vector, go ahead and use std map. Now, it's still expecting an identifier. What? Why? const expert cannot have a, yeah, sorry. Can I do this? Why is this crying? If we have put a semicolon at the end, put it in between, from our string to ints. What am I missing? So we have enum class. Oh, we use a colon, I think. Yeah, my bad. So we don't even need to do this, right? What's it saying? Non-const static data member must be initialized out of line. So static const aka must be initialized, just like that. What's the thing? Give me theirs. The in-class initialization of static class initialization static data member const table of non-literal type. So you're saying that it's not really appropriate to do that here. And I think I see why. So if I do this, when I put it outside here instead of text map, can I do this? No. Okay, let's can I make this at least const? Okay, const is okay. Can I equal this? Okay. So which leaves one last thing, is that this text map should be like, if I put this inside, can I put this inside the enum? Type traits using enum statement. That's crazy. Yeah, I think this is cool. So we're gonna make this caps lock text map, and all we have to do is text map dot merge or begin find key comp. Try, what do you do? std map. How do you find the value? Okay, so we do for const value, and then we can just loop through all of them. Okay, we can just use the bracket. So we can just do this. Apparently that's not working because no variable operator for that's interesting. If I take text map, add the type, that's the file type. That should just give me all of them, right? Tile is not declared in the scope. Able semicolon. Okay. All those creepy errors. Passing const std map as this argument discards qualifier. What? As this argument discards qualifier. M type. So we're directly passing in the M type separately. And then we're doing a text map calling the entity and giving it the string view. Okay. Let me do something. Let me make this a string view, and let's see what happens. Nothing changes. But I think string views are better because these are const stars, they're string literals. So here we can like put that there. And so now we have this. And now we can just say tile type grass. Same with this. Tile type grass. And what's going on? As this argument, what does that even mean? Discards qualifier. Update inserting value. Uh, okay, we're passing it directly into the entity, but we're not really doing that. We're just getting the value. Okay, you know what? Let me try something. Let me take like a literal like tile type graph. Okay, that's showing issues. What we're going to do is see out. We can just directly output what our text map mid this will look like, our type will look like, and we can just std endo, and then instead of here, we can just pass in like some name. Let's just pass in this texture directly, like that. I haven't even included IO stream. Include IO stream. Okay, please. What? Is it just because it's a const? Oh my god. Okay. Let me undo everything. Just because it's a const, it just discards the const qualifier. Why? I don't know. Um, Passing argument as this discards qualifiers. Let's see what's happening here. Your high method is not declared as constant at your A class, hence the compiler cannot guarantee that calling a.high will not change. So unless it takes a string view, bro, not even taking the entire thing. So unless I do something like this, which doesn't even make sense, it doesn't know. Okay, whatever. How do I then make it const? Is this worth doing? What if I want to make it const? So entity xy, and then we're passing it as this. So let's just take this as a const string view text path. Nope. The const reference to a string. Const st string reference. This should not hurt it now. Still hurts it. Well, that's kind of lame. But anyways, I'm going to remove the const for now. I'm going to study more C++ and then see how we can possibly fix this error. So I'm going to do make const. And here we have text map type. So this should work. Let's go. Let's introduce a few more. File type zone. And then let's just see. Should I make this a if I go into res and then the base pack, and then I go into tiles. We have all of this, and then we have a style sprite sheet. So if I just go into tile sprite sheet, anything, okay, .png, and then I can open that up. Here are all the tiles. So what I want to do is sort them by ID. I want to be able to provide a single sprite sheet. Like I want to provide this path, and then I wanted to figure out. So it needs to figure out the coordinates of this. Well, how big is a single thing? Let's just see. So let's file that. It's a 914 by 936. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's a 13 by 13. Why? Why is it a bit bigger on the height? That supposedly makes no sense. 3, 6, 9, 12, 13. 3, 6, 9, 12, 13. Is it leaving more gaps in the height than it is on the width? Shouldn't really be doing that. Not doing that. Can I like man and zip? I wanna the background. Enables background dash dash alpha layer. So dash dash alpha layer is equal to yes. Alpha layer. Okay. Tell me how that makes sense. I think it's a few pixels like this at the corner. It's adding just a few pixels, padding at the bottom, but not at the top. That's the only thing I can think of. Other than that, I don't know. So, because, yeah, how much? So we can get the padding then. We can say 936 minus 914. That's 22 pixels. That seems way too much. I think that's the difference between all the paddings. Yeah, there must be. I don't know. If I divide that by 13. Okay, we'll see. Right now, all I need to do. Why did I close it? Let me open foot. Why would you name a terminal foot? That doesn't even make sense. Okay. So let's load it off a sprite. Now the UV coordinate. Now the UV coordinates must matter. So we're gonna multiply it, and then divide it by 13. Do I want to make those constants? I think I'm gonna make them constant expressions here. So I'm gonna say sprite sheet path. That's going to be right, and boom. Okay. This is the path for sprite sheet. No, just like that. That's our sprite sheet path. That's a string. Okay, just like that. The string view. Okay, now it's happy. It doesn't need backslash there. We can then say sprite sheet size, width, and height. The width is going to be 13, and our height is also going to be 13. Those are ints, and that should be cool. So we have a sprite sheet path, then we have a width, and we have a height. Let me put that at the top. And now what we're going to do is move to the rows. Or should we move to the columns? Columns makes more sense. So I'm going to move to the columns. And I'm going to give all of these some name. If I give all of these some names, and then I can load this single texture once, and then I can use the UV coordinates every time. How are we going to do this? Let's see. Here we are loading in our entity class, we are loading our texture for. Okay, so here we have introduced the sprite sheet. That's exactly what we're doing. Whenever we're creating an entity, can we just directly specify that? This is a tile sprite sheet path. Same with that. So this is a tile sprite sheet width and height. Tile SS. Can I say SS? Let's leave it. We're gonna load it once. We're gonna load the texture once. And then we have to change the UV coordinate. Ugh, that's so annoying. How are we going to do this? Instead, yeah. Okay. We take in our texture path, and all we do is just load it. Nothing else. Just load the texture. Now, what's dependent is this, right? Here, when we're specifying our U and V, oh my god. Here, when we're specifying our U and V for our vertices, we want to be able to change those. This needs to be different. And how are we going to do that? That's a really good question. Because if we use our vertices into and we input that into the buffer once, that's just going to render that. That's like an entire entity on its own. Right? We have our VBO here. We create a vertex shader, then we compile that shader, then we compile our fragment shader. Then we add that to our shader program, then we use our VAO. Then we add, and then we use our VBO. In our VBO, we add the entire buffer data. So our VBO now contains that one. We don't add it again, and we use it for static draw. Then we use the position attribution to get our position, then our color, then our text coords. And now this is the difference, right? We basically want this to be a uniform. But it only needs to be loaded once for whenever we're creating the object. Let's see. We have our tiles here. And then we just create a tile. Once we bind the texture to a tile.getText. You see that? So do we want to fit the buffer data again and again? Or do we just put it as a uniform, or U and V? Because that tile could change, right? That tile's texture could change. Let's say it's a sprite sheet, and that should be able to like change. If it's an animation, it should be able to change easily. Yeah, this looks like it should be uniform. So as OpenGL sprite sheet UV chords as uniform. Is that normal? Let's see. What do you end up doing? What does it say you should do? Unless we put all of that into like we just feed it into our shader. We just feed the types into our shader, and then you can just automatically grab that. Yeah, I think that should be a better idea. But our UV, yeah, we can just change our UV chords based on our GL point chord. No. What the hell is this? Okay. I did this way. I made 11 quads like this. Ew. Okay. We use the indices, then we aren't even using the UV chord. Am I dumb? We aren't using Levy chords. Okay, here we take our sprite index and we multiply it by time, and then float sprite position is equal to whatever. Then our vec2 chord is equal to x minus the sprite position times the mass. So there are multiple ways of doing this. One way is we could just calculate it inside the fragment shader when we're taking in the text chord. Instead of just directly feeding it into this, we can check what tile type it is. Yeah, we can check what tile type it is, and then we can just change it based on that. Because text chord, yeah, all of the calculations could end up here. If we so since this is from 0 to 1, we need to divide by our tile size. Yeah. So there are two ways. We can put the entire calculation here. We would have to feed our tile size here. We would have to feed. Yeah, that's it. And then the width and height. Width and height and the. That should be it. Width and height and the total amount of tiles in the sprite sheet. Or we can just calculate that even. So sorry, the tile size in pixels. If we get the tile size, no, we don't even need that. Which means we actually don't need anything. All we need is just the tile width and tile height of our sprite sheet, inside our sprite sheet. And if we just make that a const, I actually don't want to make it a const. So instead, I'm going to take this uniform. I'm going to say, what is it? Effect2? Is it effect2? Tile width and tile height. So tile width const uniform OpenGL. Because if we have a constant uniform, like constant float values, but we want to externally feed them, if I use again because my flyer is not constant. However, this is perfectly valid. Why? Because meaning the my float value is doing a while time to unroll the loop that value is a uniform that can change each other that cannot be unrolled until runtime. I understand. Is it necessary to make this a const? I mean, the sprite sheet can change at any time. So I don't think that's really a problem. Yeah, I don't really think that's a problem. So I can just say tile size. And tile SS size. Tile size. I'm going to say the sprite sheet. SS is equal to sprite sheet. We can have all of these. All we need to do now, tile SS size dot ugh. We don't even need the width and height, we need the amount. How did we no. So the style sprite sheet width. So sprite sheet width in second. Just a second. Okay. Let me put this back to main. Transition. Okay. So, what are we going to do here? This tile sprite sheet size. This is in terms of width, like the amount of tile. That's what we want. Sprite sheet SS equals sprite sheet, and this is the amount of tiles uh, in on X and Y, on X and Y. It's just roughly for my note taking. So tile sprite sheet size on our X. Okay, you know what? Let's just do count. Count. That's better. So tile sprite sheet count on our X, which means our uh width. Then we can take the text chord. So now our text chord is from 0 to 1. Sorry, it's flipped here, so it's actually 0 to 1. No, 0 to 1. Yeah, it's from 0 to 1. Our text chord is already. So it's on the bottom left corner here. We are scaling like this. So this is 0, 0, this is 1, 1. We're going to divide that by our count and then add to that the actual tile. So we also want to add to that the actual tile. So let's add to that the actual tile. Yeah, we can just say which tile it is. So tile SS index. And we can say the index of tile in terms of tile. Okay, we are going to add. So this is a single one. Let's just create this into a variable. Let's just create this into a variable. Let's make this new lines. Add new lines to here, and we can make this a const float. Is this a float? Yes, this is the float, and this is a single tile's width. So a tile width. Tile width is that. We can just say a tile size from 0 to 1 is just that. Will that even work? Can we just directly do that? I don't know. I'm gonna have to find out. And so in here, we're going to take our tile size, multiply it by the tile SS index. Yeah. So our tile size, if we've divided that into count of our X or Y, we're dividing our text chord by our. So yeah, this I'm just gonna. What am I doing? I'm gonna make this a vec2, and I'm gonna put this. So this is dot x, and this is dot y. So now we have our tile size. We're gonna take our tile size dot x. This at the end of the day needs a vector 2, right? This needs a vector 2 for our text coordinate. So on the width, it's tile size x. So we take our x of our tile size. So we take its width. And then we multiply it by our index. So let's say it's the third, so it multiplies it by 1, then multiplies it by 2. Now we've got it from here. It's a text chord. Yeah, so that brings it. Is the text chord at the bottom of the picture, or what is it? Here we're putting it at each vertex. Oh, so this is why we needed the vertex corner. How do we do that? Get vertex corner Sprite sheet. GL vertex ID, I think. Fader. Yeah. So GL vertex ID, this variable provides the index of the current vertex within the entire primitive, triangle, line, or point. In a quad, which is commonly spread, we can use GL vertex ID to determine which corner you're processing. Yeah, so it's going to be okay. So we're gonna have to do something. This is going to be if if yeah, for now I'm gonna do it manually and then vertex ID like that. If GL vertex ID is equal to 0, and then this is going to be spaces, new line, and then it has to do something. Let's remove that. And in terms of tiles, okay, that's fine. I don't know why I decided to do this. Here we're going to do this, then else. Yeah, sorry. I'm just focusing too hard on this. So we have our vec4. Now, if that doesn't work, else if GL vertex ID is equal to 1, we can put a new line here. Then we can have our, so let's just make this a separate thing. Just make this a separate thing. Yeah. Cons for Control Q, Control J, and Emacs is goaded because you can just ignore the indenting and we can just follow along. So we create a tile size, then we need to create not a const, but instead of a tile size, this needs to be what is that? UV chord? How do you say the text chord, right? So if we take the input text chord, and then here we're gonna say the text chord finale basically, and that's going to be a vec2. So we're gonna say vec2 text chord, and we're just gonna do that. I hope that is an error. And so we can just put that there, 1, 2, 3, 4. And inside here, we can calculate all of the variations. So this should be text chord. And here text chord can be equivalent to that. And that allows us to easily change our text chord. Now, what is the second last case? That is of 0, 1, 2, and 3. So else if that is equivalent to 2, what we are going to do is dependent here. And then Control D, Control J for else if GL vertex ID is equal to 3, line, and then we are going to just do this one last time here where we can calculate that at the corner. So now we are always going in the order of top right, bottom left, top left. So top right, bottom right, top right, bottom left, top left, bottom left, top left. Even so, indices won't change that. Will the 0, 1, 2, 3 correspond to the 4 vertices? GL, yeah, OpenGL sprite sheet shader. Come on. how would that be done? Is it using GL vertex ID? GL vertex ID sprite sheet. Come on, please, please, please. What? So we're creating a static U32 vector 2 with some prototype attribute. Then we're doing some more goofy things. And then we can just get the ID. Yeah. Because here, what we're doing, you know, can't we just manually multiply that? So if that's 1.0, it's 1.0 on the width can be changed to something else, right? We don't even really need this. We don't really need all of that. Just purely based on the fact that our vector text code can be changed. So let's just move this. Let me revert the buffer. Yeah. So our text chord is supposed to be our x and y. Now we're gonna take in whatever f text chord was, right? If it was 0, so we're gonna have to add a tile size scaling constant to that. So we're just always going to add our tile size multiplied by this. This is giving us the exact coordinate. Yeah. In from 0 to 1 of that inside our tile size. So we're just going to add our tile size multiplied by the tile ss index dot x. That's just it. Once we do all of that, then we can add to that. Yeah. So we've taken tile size times our index and times our width from 0 to 1. That's gonna give us the 0th. Then we're going to add to that whatever f text chord was, because that's from 0 to 1, and we're going to divide that by our multiply that by our tile size. So if that was 0, that would just not add anything, which would mean it would be at 0. If it was 1, that would just multiply by tile size. So we can use this exact same logic. And I'm gonna have to put it into a file soon. Okay, fine. I'm just going to. I'm not gonna put the new lines and all of that here. I'm gonna put that here and just like that. And this is going to be our y. Just like that, we're done. We don't need any of the text report. I'm gonna leave it here because it took too much time. And once we're doing the output color, we can just use the text, add the text port, add our new text port calculator. Okay, now all of that's cool, but we didn't provide the SS count and SS index, right? SS count and our SS index. So we can tile SS count, tile SS index. It's a vector 2, by the way, right? It's a vector 2. Yeah, SS count and SS index is a vector 2. Seems about right. Let me just copy both of these. And once we're searching for the attribute, yeah. So we're gonna take our attribute. here we can just correctly find the int file ss count attrib location. Honestly, we can just lowercase this, lowercase, lower case, downcase, do what I mean, and then gl get attrib location of our shader program, and we're gonna get our no, this is not, this is the attrib location. We want to get the uniform location right here, like that. We want to, can we directly specify the uniforms inside the fragment shader, or do we have to do that in the vertex shader? Let's see. Uniform projection uniform location. No, it's going to be whatever this was. Okay. Again, sorry for that. We have we can set our um, file ss count uniform location to whatever it wants. So this is not going to be a matrix for FV. Instead, this is going to be a GL uniform. GL uniform 2F. 2F versus 2FV. 2F versus 2FV OpenGL shader. Number of floating point. 2 floating points used for various purposes, including that spec2. And what the hell is this? Can refer to the number of floating point values passed to it. That didn't explain anything. For the scalar command, specifies the new values. No. No. What am I asking? Okay. FIUV. GL uniform to FV can be used to modify a single uniform variable or a uniform variable array. These commands pass a count and a pointer to the values to the loaded uniform. And these specified by location. Okay. Wait, what? If I can just directly 2F this, and then it asks for the 2 floats. Right, and if I do V, that gives me a count and the value. Okay. So I can just specify it here. So glint location, then we have a count 1, and then it's asking for the value, so we can just give a value pointer to the to our style ss count process count, and we can say that's a glm vec2, and here we can say glm vec2 upon here, and tile width and tile height. And we're going to have our index. Too many interruptions, and I'm gonna have to end the stream for that, but not right now. I'm just going to tile SS count here, and now here we have a uniform location, and then we can just use the index uniform location and tile SS index. And here, yeah, this is why making it a uniform was a good idea. I can just directly specify the index through the X and Y by noting the tile type. Now this map here is just a text map. But for every tile type, I also have like two other things. Uh, let's see. Enum class C++ multiple type. Like, so we can do a colon char colon int, and then we can do a colon variant, and that's going to be something on its own. We can have an in class type, and then our value, which would hold the type, and a variant to the data, and then we just create it of the value type int value, and we can specify that the type is an int and the variant is a data. Now this is not what I'm looking for. Can enums hold multiple values? Like that? That's crazy. We have a fruit type, then we have a class fruit. You see, in the my fruit, no, that takes in a fruit type. That's not what I'm saying. So unless we make a tile type thing, like this is a text map. Okay, maybe we can just make another map. Instead of text map, let's see what rename this, by the way, from text map to tile text map, and then we are going to have another one for the, what do we want it for? From our tile index, from our sprite sheet index, it should SS index map, sprite sheet index map, right? And so our grass is where? For now, we can just specify that this would be a. Can we make this a GLM vec2, or should it just be like from vec2, and then we can just say 0 0, and then we can say 0 1, right? I think that's fine. Yeah, I think that's working. Let me revert the buffer. Though that seems fine. So here, when we have to specify the index, we can just take the tile's type, and then we can just know, right? So our index will be our tile SS index map at the type of this tile. Tile.getType. I didn't make that a thing. Ugh, why does it be so annoying? So we can just get type, and all that has to do is return m_type. So we create the getter, and now we can just get type like that. Same thing. Oh, so we don't even need all of this. We can just directly put it in, and that's all we need. Boom, just like that. That's beautiful. So we can say our count and index. Make our count, and our index. Okay, I have zero faith this will work, but let's do compiler. What do you call it? It's like, I think compiler guided debugging. So warning, tile size must be a constant expression. Too many parameters to vec2 constructor. The fragment shader failed. Okay. Let's see what the fragment shader is doing. Initializer of const variable tile size must be a const expression. We don't want to make this const. Now it's saying that the tile size was uninitialized. Okay, well, we clearly defined it in tile size. And then tile size used uninitialized. Where is it using tile size? It's only used after that. Like if I do this, and if I do this, so if I like copy this, and I paste it into tile size, then if I copy this, and if I paste it into tile size, and then I make this, I comment that out. Tile size is undeclared. Who's using tile size now? Oh. Oh my god. Okay. Like that. But that should be why. Please work. Whoop. Is this like a memory issue? My CPU and RAM has jumped. Yeah, something's definitely wrong. Stuck in a sort of loop, maybe. Never mind. Too many parameters to vec2 constructor. Where are you giving that? We put a comma here. And then we ended it here. It's a vec2. Also, this needs to be like a U tile size. U. We need to declare this up top before we can even use it. I think we have to say float tile size, new line, and then we can do this. Like, okay, let me just copy that line and do everything we've done. Yeah. So then we can just do this and do that. And we just set tile size to whatever we want. And we can make this, let's replace that with U, and tile SS count with U, and here with U2. Then our index is also a uniform, so we can just do that. Please work. Okay. Now it's saying too many parameters to vec2 for this too, which means I don't know how to initialize a vec2. So OpenGL shader vec2. Yeah, how do you even create vec2s? How do you even create vec2s? Where? r/OpenGL. Bro, what? Vec2. So whatever, and then vec2 and then 2. And that's exactly what we did. Oh, the text chord. Yeah, the text chord is an X and this is a Y. And this is F, this is X and this is Y. Okay. My bad. My bad. I completely overlooked that. Value of type vec2 cannot be assigned to a variable of type float. It's the it's the inverse error now. Oh, no, tile size should actually be a vec2. Bro, what? Not again. Too many parameters to vec2. We take this X, fx chord is a vector. We take the X, then we take the size count, we take that X, here we take the Y, and we take the Y. So, and then you put that here. Warning text chord used uninitialized. So we need to do that again. Vec2 tile size, vec2 text chord, and we can do that here, like that. At least one of those warnings will go away. I mean, the only warning. And now for the too many parameters, here we're using tile size as a, oh, what am I doing? Okay, no, it's fine. Maybe it can be a vector. So we can get its y, y's, and now look at this. This will work, right? Okay, I think I know what's happening. First of all, we've done some maths wrong because that's weird. Second thing is I provide the wrong thing to the wrong thing. You know what I mean? Yeah. This should take the tile sprite sheet path. And so when we're passing in the entity, once we're giving this a type, we don't, okay, we can give this a type and we'll set that to us. But here we can just say the sprite sheet tile sprite sheet path, just like that. That should, it's interesting. Definitely trying to do something. Definitely trying. I do not doubt that at all. It's trying very heavily. Tile sprite sheet path. And so technically we don't need this. We don't need the map. Yeah, we don't need the map. All we need is the index. And our M type can be located with this. So it has tried to do something. Let's just see if I can, directly do that. We don't even need to. If anything, if we're dividing two vectors, it's going to automatically going to apply the same operation to both. Now that's interesting, right? Why? So both X and this should be tile size Y, and that should be tile size X. It shouldn't matter though because the tile size is the same. Ooh, it changed up. So we take the tile size of our X. How we're doing that is our F text chord, which is from 0 to 1. Oh, but it doesn't have to be from 0 to 1. So 1.0 F upon U tile SS count. What? So we're taking our tile size, which is 1 upon our 13. So if I have 13, it's going to take the 1 upon that. Then it's going to take our tile size dot x multiplied by our index. We have 0, 0. It should just multiplied by 0. And 0. But it depends on what vector we have. Are we multiplying it by f-text coord? Where are we using f-text coord? Okay, here we are. So we've taken that 0. Then f-text coord.x, which is 1 times tau size.x. So let's just see. Let's just map this out. So we have top right, which is 1.0 and 0.0. So that's going to say 1.0. It's going to take that. Sorry, it's going to take that. And then it's going to take 1.0. Let's draw this. It's going to take the sprite sheet and going to take the 0, 0. Now, if you want 1 and 0, which is apparently the top right, it's going to multiply that 1 by the tile size. That is 1 upon 13. That's what it's going to multiply by. Yes. And then it's going to take the y and do the same thing. But the y is 0. So that's also going to be 0. And so y is going to be 0. That seems beautiful. I don't know why it wouldn't work. Tile size dot x multiply by this and then the f-text coord and then tile size. And we can just directly do that. Do some diddly doos. What it's doing is 1, 2, 3, 4, 5, 6, and sum. 1, 2, 3, 4, 5, 6, and almost 7. See if it changes. Hope it doesn't. It's taking the tile size. Maybe we set it wrong here. We take the SS count. And the tile SS count is from here and from here. Like how we did this. And the tile SS count, we take the uniform location and 1. And then we GLM value pointer to tile SS count, which is width and height. And for the index, we just get the tile SS index map, tile.getType. So let's just arbitrarily put in some things here. 0, 0. And let's arbitrarily look at 13 by 13. Let's see if that works. I don't remember writing 30. It worked. Okay, that's crazy. Which means I never set tile width and height correctly. Tile width. Oh, tile sprite sheet width. That's fun. Here we want tile sprite sheet width and tile sprite sheet height. There we go. There we go. We've got sprite sheets working now. Let's go. Isn't that cool? So, anyways, I'ma be back. Maybe I can end the stream. How long has it been? It's been 2 hours. I think I'm gonna take a break. But this is small break, right? So let me rename that to a small break. That's the name already in use. Rename that to, okay, you know what? I'm gonna rename this to a text. So rename this to a small break text. And this break can be renamed to small break. And we're gonna duplicate this. Big break. And instead of, so break around instead of 5 to 10 minutes, 30 minutes to an hour. 30 minutes to an hour. And that's okay. We're gonna rename this as well to Big Break Tech. Let me center that. Center the screen. And I'm gonna be back. Oh my god. We're gonna have to add some separate tech. Small tech. Small break tech. Small break. 5 to 10 minutes. And it's not sans serif. I hate that font. I need ISFka. And one. Come on, you can do it. Apparently not. I can't do it. Come on, let me edit it now. Okay, and this can be transformed to the center. Now we have two separate things. Save that. Going to big break. Thank you. I'm gonna be back. I have to eat. Sorry, I was muted. That was a pretty big break. I'm sorry for that, but I had to eat and do a couple more things. But anyways, we're back. It's at the 3.5 hour mark. So, what did we cover so far? We had used a sprite sheet and figured out the tile sizes. Isn't that amazing? Let's see. Yeah. So, what was left was trying out more indices, and let's see if that works. So, on my index map, but I'm still surprised that worked. Like, that's crazy. So, maybe if we made this 0, 1, let's see how that would work. Okay. And at 1, 1, let's see if the coordinates line up. That lines up perfectly. Okay. Which means all we have to do is just actually name all of these. I don't think there's a great way to automate doing all of that, but I think I'll just open up the spreadsheet in one corner and just keep on adding the tiles I want to use. I won't add them all at once, and I think that would help me cut down on the workload. So let's try. Nziv, res, base pack, tiles, and then the tile spreadsheet row. Oh no. Tiles, spreadsheet. So let's see. What is there here? Our grass tile. Oh, so there are connecting ones and the non-connecting ones. Um, because if we have like based on these three grasses, what I'm thinking is if it's on the ground, it would be like this. If it's on a ledge, it would be like that. So should it automatically calculate what it should have been? Like only within these three. I don't think we need these air ones right now, but just these two. This one's in the middle and this one. So what? And then we have some stone too. Mm, so we have a full dirt block. We have a full dirt block, just like this. I think I'm gonna use that, which is at what? That's 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 8, 8, 12, because it's at the end. 8, 12. So we're going to do a grass. We're just going to do a grass, and then a grass left, grass middle, grass mid, grass left. Should I do that? Grass mid, grass left, grass right. Um, and then we should have a dirt block. So dirt, dirt full, or dirt mid. Um, yeah, dirt mid. So I'm gonna name these right here. M is equal to mid, R is equal to right, and L is equal to left of the block. So we're gonna have a grass M. We're gonna have a dirt M first. So dirt M was what? I forgot again. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's 8. And 12. And starts off at 0. And we have the 1 minus that, that's 7. And we are having that if that's 12, 11, 10, 9. 9, 8, 7. So 9, 8, and 7. Let's indent all of these. So we have a left. Is that a left? Okay, so we have a right, middle, and left. So right, middle, and left. Which means if when I'm creating these tiles here, it should be grass middle, and let's make one of them uh, dirt middle. See if that works. That should just work. I haven't really changed much. Ooh. So there is a significant padding. Hmm. There is a significant padding. I think how much is that padding? Do we not know the padding size? Like, hmm. At the corner, you can see there's a bit of padding there. That's applied to both sides, just one side, right? And in this corner, there's also just the padding on the bottom side. There's none on the top, and likewise, there's none on the left, but there is some on the right of each block. You know, let's see if that's 914 by 936. So let's just calculate the difference. 936 minus 914. That's a 22 padding on the height. This is width and this is height. So I'm gonna minus the height by 22 divided by 13. I'm gonna subtract from the height right over here. I'm gonna subtract from the height. Where are we doing this? Here, right? So, okay. Let me undo that. Tile size is going to equal tile size minus 22 divided by 13. It's a float, right? It's a float. It's a vec2. Should work. Maybe. Who knows? Yeah. This should also be dependent on not just the 13, but the index. Oh, that should be divided by 1. So instead of just 1.0 upon tile count, we need to subtract the tile size. Okay, no, not like this. On the text board, okay? So we're taking our tile size, we're multiplying it by our thingamajig, you know? And so what we need to do is text4.y minus 22 upon 13. But I think that should oh my god, that should change. Value type float cannot be assigned to variable of type vec2. So is there like a okay, text4.y minus equals? Can I do a minus equals in GLSL? I can. That didn't change anything. So we're subtracting 22 divided by 13. If I subtract that from our x, that wouldn't make any sense. Maybe if we add it to our x. Okay. So that definitely did not work. Um what we're drawing right now is 7/8, right? 7/8. So trying to do that here, and the part that it's grabbing is it grabs a chunk of the left. How does it even do that? What? How is it even grabbing that? Which part of the sprite sheet is this? So let's just see. So there's just a block of dirt on the right, and then there's some thing on the left with grass. Can anybody see that there? That's that. That's the last one. How did it reach the last one? Yeah, there's no other way. It's just the last one. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's dirt M. And when we're creating the tiles, we made one of them grass M and then one of them dirt M. So what I'm going to do is tile width, tile height, and then tile width times 2, tile height times 2. Let me just see both of them. Not this. Let me just see how both of them react. So, okay. First of all, that's okay because we have to multiply by 1.5. Anyways, that's so weird. It grabs like a chunk. It's not adding it properly. It's not adding enough. It's like it's not adding the padding. Adding the paddings. Let's see, what is it doing? It's not adding enough. The text chord tile size plus F text chord times tile size, but only on the X. It's not adding enough only on the X. So we add. Let's see. We add 22 because there was a difference of 22 pixels. Oh, because that's 22.1. Am I even recompiling? Nothing is changing. The text chord should be like added in percentages, right? So 1.0 upon, so it must be 13 upon 22, right? That's goofy. That's goofy. If there really is 13, unless we are not figuring out the tile size correctly, because that must be 22 upon 13, and then we can just quotation that out. That's definitely not it. Maybe if I okay, maybe if we just change the tile sizes X plus equal 22 upon 13. Let's see what that will do. And put semicolon. That's not it. So since that is such a big, okay, so maybe 13 upon 22 because 1.0 upon that literally added nothing. Can you see that? Added absolutely nothing. What if I just add 1 upon 22? Hell no. Yeah, so that's not true. You know what? For starters, let's just try 1 1. Let's try 1 1, and let's see how bad it is. But that's the stupid part. This sprite sheet does not like count that there. So that seems all right, but I don't know exactly how much it's offsetting by. So if I do like 0 1 2 by 2, even that won't show it to me fully. So okay, I have an idea. Let's do 0 1 2, right? Let's do 2 0. 2 0 will show us if there's any difference on the. Oh, whoops, 0 2. It's on the y coordinates. That seems perfect. That seems exactly what we would want it to be. That seems absolutely amazing. Okay, now let's try out the x. So we would need to be like this one. So 0 1 2 3. I keep closing this terminal. So we have 3, 0. We would need to recreate that. Okay, so our X has this much difference. And at the end, it has quite a bit. Now, what this difference is exactly that. So let's just sit here and multiply. Let's do some maths, quick maths, right? Let's do some math. If, first of all, let me get the file size of that. File. It's 914 by 936. On the Y, this is perfect. But on the X, we're doing something. We're overshooting. We're overshooting by how many pixels must be in 22 divided by 13. Maybe it's divided by 12, or maybe it's divided by 14. It doesn't evenly go into any of these. Why would you make your sprite sheet this goofy, bro? Okay, I have an idea. Let's check how big this is. I think it was, what was the command? It was like magic show, magic, and then just the file. Like, how do I open magic, open file, image magic, open your picture. How do you open a picture? That's with Python. Okay, in any case, I think we're just directly going to shift our focus outside. 914 by 936. We have our sprite sheet at 914 by 936. And we're trying to divide this by 13, and that works perfectly. But it's almost like there are 12 pixels missing. They're plus 22. There are 22 pixels that need that's like a deficit on the X. And 22 divided by 13 isn't really a number. So maybe 21 divided by 13, 12. Okay, that seems reasonable. Or 14. That also seems reasonable. Or it could have been a 23 pixel deficit. 13, 12, or 14. That doesn't make sense. The only thing that really makes sense is if it was 21 pixels and we're using, if you divide by 12 or we divide by 14. What this means is we're saying there are 14 tiles or there are 12 tiles. Because in this case, it still doesn't make sense. 1.615. Did I count it correctly? There's no way like nziv alpha layer 1, 2, 3, 4. Okay, we're back again. So, where was I? Where was I? Where was I? Yeah, we were trying to figure out why we were lacking 22 pixels on the X when we had them perfectly divided. And so, if we go into calc, 936 divided by 13, that's perfectly 72. But we're missing some pixels uh, here. We're missing exactly 22 pixels. Now, if we have 72, we have 72 tiles. We know that for certain. Sorry. Uh, each our tile height is 72, which means our tile width must also be 72. Now, if it must be 72, the difference in x. So let's say there are 22. This is 22. The height of this is 22 pixels, but the width of this must also be 22 pixels, right? Sorry, 70. What was it? 72. 72 pixels is its height. So its width must also be 72 pixels. Unless we're having a few pixels padding here, which we need, and a few pixels, there's less padding on the X. Because the 22 pixels that we're missing on the X here, the deficit on the width, we can distribute that onto each tile, but that won't really give us something, right? Versus if we say instead that was around 70, 71, 72, 73, the closest, maybe 21, 22, 23, 24. So 24, if I divide by 24, maybe there's 2 extra pixels there. So if I say there was 24 pixels, each would have a padding of 3, which still wouldn't make sense. So 3 padding on the right, 3 padding on the left. So let's just see if on the X we can get like 12. If there's absolutely anything wrong with that, we should get this crate in the corner. Should get this crate in the corner. Let's see if that works. The crate renders perfectly. So again, the Y is perfect. The X is a little shifted, maybe. Maybe it's stretched. Does this look stretched? It does look a teeny bit stretched. Maybe that's just because of my nons in my 9 ratio. Yeah, so it won't look stretched. I mean, I don't think so. It doesn't look stretched to me. Um, we're even grabbing some of the bottom line. Yeah, here we're grabbing just a singular layer of pixels at the bottom. Right there. But it can be ignored, right? What can be ignored is what's happening on the X. Ugh. That's weird. That's also weird. Um, okay. We're gonna set this to 0. And all we want to look at is just the last. I don't know why. Sorry, we want to set it to the reverse. So now we want to see the top right texture in the sprite sheet. Oh, it's not accounting. It's not accounting for those 22 pixels at the end. Look at this. If I open up the sprite sheet, This is not a valid tile, you see? That's like a weird half tile. So the 22 pixels that are missing are exactly on here. And if I do 72 upon 20, bruh, 72 upon 22, that's weird, Mick. I don't know why he decided to do that, but the tiles at the end are different sizes. The tile on the right, why would he do this? That's so goofy. Look at that. Why would you do that? Should I fix this sprite sheet up? Look at that. That's one of the dumbest things I've ever seen. Oh, you know what? I don't even need this, whatever this is. I'm just gonna remove it from the file. I'm just gonna absolutely, yeah. So I'm gonna go here to my other tab. I'm gonna put this here. I'm gonna open Krita again. It's the same. And inside Krita, I'm just gonna remove that grass rod thing. It's so weird. Why would we ever need that? Oh my god, my history of what I've been doing. I actually have to create mnemonic using the memory files technique. So I edit some of these to just make them fit into a single picture. Uh, anyways, we're going to use the content, the script. Okay, let's just use normal dimensions. Ugh. Maybe if I open image, I can open image, go into EDU. I'm gonna go into EDU and I'm gonna select that. Where am I? I'm gonna go into the project directory, go into the res, open the base pack tiles, and then open the sprite sheet, file sprite sheet. Okay, so with the sprite sheet, we're gonna have to completely crop out that end bit. Yeah. So for completely crop out that end bit. Oh hell no, not this. We need the crop tool. Crop. Where is the crop tool? This right over here. I'm gonna grab that out. Right, I'm gonna grab that out here. This though, I'm gonna completely remove that just by a single pixel. There we go. Since we had the padding at the bottom, right here, we also had the padding at the top. No, we didn't. Every single block has some padding at the bottom. So are we including that? Yeah, so I'm gonna hit enter on that. And then I'm gonna absolutely remove whatever this crashes. I'm gonna put on the eraser. We don't need any of that. And let's make sure we're not removing any of the tiles. Opacity is 100%, but it's still kind of weird. Let me, yeah, this is normal. Do we have like the hardest brush? In eraser mode. Gonna carefully. I know I could just box select it, but I'm gonna be a retard instead. Okay. Boom. Right? Just like that. And so we're going to save this on that. And now, once I look at this, wow, look at this now, and everything's going to fix. Except it's going to have one less column. So the sprite sheet width is going to be 12. Height is going to stay 13. Let's just see. Look at that. We fixed it. Isn't that cool? I think that's pretty cool. So we can have 12, 0, and then we can also have 12, 12, or maybe what's the last? 12. It will be 11 on the X, and then on the height is going to be 13, or one less than that. So yeah, 11. No, so 10, and then 12. Yeah. So we have that perfectly. We have just a single pixel line on each end. We could calculate that. Let's see if that's too much of a bother. I'm not gonna force it. So if we have 72 tiles, we have 13 of those tiles. 72 divided by 12. That works out perfectly. Let's see. Let's just calculate how many pixels that is. Let's make that to 1. Make that to 1. And we're not gonna set this to eraser mode. Why is this still soft? Can't I like? Where is a pixel art brush? Just a square hard brush. I just need a pixel art brush. Oh, pixel art. Boom. There we go. That's all I have to do. Anyways, there's 1, 2. So there's a 2 pixel padding here, and even at the end, I'm gonna zoom. There's a 2 pixel padding here. Yep. And then there's also a 2 pixel padding here, and even at the end, right there, 2 pixel padding. I have a 2 pixel padding. It's not gonna be at the top. Not. It's gonna be at the bottom. Here you see 2 pixels there and 2 pixels there. Which means that we have a 2 pixel padding on each side. So I can just subtract that, but I have to find out how much that is in UV coordinates. Let's just go back. Let's just go back to our shader and let's recheck our map. So here we are saying that our tile size 1.0 divided by U tile are as a uniform. Our tile sprite sheet count. So we're just saying in UV coord, since it's from 0 to 1, if we have a count number of those, so let's say we have 14 tiles, we're going to take 1.0 divided by that, so we can get it in UV coord, and then we're just going to multiply it by our index, which tile it is, and then we're going to multiply our text coord by that. So if it's 1.0, it's going to automatically set it to 1.0. So this way, I don't have to use the GL vertex ID. I have to do that. But the padding is still left. Let's just check once more. Is it on the right or is it on the left? It's on the right there. I'm thinking we should just, I don't want to subtract it from our tile count, but I want to add it to our text coord. So for every time we're jumping in our tile size, here we're jumping in our tile size, here we're actually using that for a coordinate. So every time we're jumping in the tile size, I want to add something to that. I want to add 2 pixels to that. And I think, but this is tile size in pixels? No. That's lame. Our tile size is in UV coordinate, and we just divide it by 13. Okay, so we need the resolution of the picture, and then we need the padding. Either we take the resolution of the picture. So this is option A. Either we take the resolution of the picture, and then we can just divide it by 2, which we can just do it here, right? Let's just do it right now. So if I take this, if I take file, and I see how big it is. What? Oh yeah, because I've completely removed one column. But 864 plus 72 is 936. So 72 pixels, including the padding. So it's 70 pixels per tile. Each tile is 70 by 70 pixels. And then there's 2 pixels padding on each side, on the right and on the bottom. Sorry for that. So we have 2 pixels of padding on the right and on the bottom. So if we just manually add that, like if I see, oh, 2 in how 2 responds to 936, like 2 out of 936, this this is the exact value we want to put in there. So you know what I'm gonna do? I'm gonna take this. If I can do 2 times 13, that's 26. No, I just need this. So I just need the padding in that amount. So I'm gonna say padding to width ratio. I'm gonna take that in. Padding to width ratio. Uh, file SS padding. Yeah, padding, and this is in terms of just a float. It will be floats. It will be like padding per tile divided by a padding per tile divided by the total size. Padding per tile divided by the uh, sprite SS width, SS pixels, SS width in pixels. Um, yeah, SS width in pixels, and adding pixels per tile. So let's actually implement that, right? Tile SS padding. So if we have index here, and we can have a tile SS padding uniform location padding, and then when we can see our index here, we can simply set it to we can set it to our what do you call it, count index padding. So we can just set it to our padding. PLM vec2, that's going to be padding, inside our vec2 we can include the padding in pixels. That's 2 divided by our sprite sheet width. I'm gonna get that. I'm gonna get that here. So I'm gonna say const expert padding or tile. So we can say tile padding in pixels. So tile padding in pixels. Tile padding in pixels, and then we can have the size ss ss width in pixels. So tile sprite sheet with pixels and height pixels, and I think we can just get that. We can just get our width and height from within that. How do you even do that? So this takes in it uses int text width and text height, and then once we load that data in, and then it just stores that in there. How do I do this? If I use mtextpath.cstring, I just want like the width. Can I? Maybe there's stbi with stbi get picture width. Yeah, peek and file to check width and height. Like, how do I just check the dimensions? stbi info. Okay, width, height, and what's C? stbi info. Let's try that. I'm going to not do this, and then font, not even font. And let's see if I can say stb info from memory or info main. It's gonna take in an stbi context. Oh, this is a internal function. stbi info from memory is gonna take in the stbi buffer. Should I just directly put it into entity? Like, can I just use the mtext width and height? Like the texture width and height? Just grab that. If we're loading this into here, this text width and height can be equal to tile sprite sheet with pixels, but only if it's the sprite sheet. Okay, for now I'm just gonna use stbi info from memory. It takes in a stbi uc constant buffer. What am I gonna do with this? What am I gonna do with the buffer? A buffer? stbi uc, like an unsigned char, like this text data. So if I'm using the tile, might as well, right? So let me just get that text data. And why do we have to do it again and again, right? If we have loaded our text data in once, I don't think we need to create it again and again. But that would only apply if we know what type of entity it is, right? This just loads in the texture. It does not ask you what type it is. So let's just say if it was a tile here, it's taking a tile sprite sheet path. So you know what? I'm just gonna make some protected variables. I'm just gonna make some that's private. And I'm gonna make some protected variables. And here, this is going to save our all of this. And I'm gonna make these members. So eglot rename to m text width, and I'm gonna rename eglot rename that to m text height, and I'm gonna eglot rename that to text channel count, but m underscore text channel count. And so what's gonna happen now is I don't need to create the variables. I can just put that into here. And so I can just manually manage that. Once I've loaded in a tile sprite sheet path, I don't need to do that every time an entity is called. So I can optimize that, but I don't want to optimize it right now. If I just pass in this right here, as soon as we are creating this constructor, after we've run the constructor, we want m texture width. So we can say tiles, right, sheet, width, pixels is going to equal that. And same with our height. Height pixels, height. And so that's cool, right? That's cool because now we can just get tile, tile padding. Tile padding. Tile, right, sheet. Honestly, that's so annoying, but okay. Tile, sprite sheet, padding. Upon tile, sprite sheet, width and height. So that's going to be width, and then that's going to be our height, width and height. Or I can just do a tile sprite sheet dimensions, and then make that like a GLM vec2 tile sprite sheet dimensions. And this can also be a GLM vec2, and that can be organized like this, 13, 13. That's the total padding? No, I think I didn't initialize it. So it's, yeah, it's tile padding. Tile padding. Wait, what did I just change? It's within pixels. Okay. So why is this crying? Declared font here. Okay. I was changing the wrong thing. So here I'm going to put, it's not with dimensions. This is just dimensions, the tile sprite sheet dimensions. And I can initialize them here. So dimensions m text width, m text height. Can I just do that? Can I do that? Let's go. So we have that, and then yeah, means I can directly tile sprite sheet dimensions, tiles sprite sheet padding. Oh, it's just tile padding. And that's const expert. That's fine to be const expert. Okay, okay. So tile padding upon file sprite sheet. So this will give it from 0 to 1. This will give how much padding we need to put in. So if I go up top here, inside here, this is going to, we can just simply add the utile ss padding. So this is how much a single size padding takes. So we can just take that. And hopefully now, I really doubt it, but okay, but there's still a single line there. I do not know why. Because it's on the tile side of the thing. It's jumping the right amount, It just needs to fix that on its last tile. So in the jumping, it's fine. But once we're multiplying it by tile size, that's when you need to add the utile SS padding. Never mind. That's crazy. The utile SS padding would be padding pixels per tile, and then SS width in pixels. So it's going to give, what 2 pixels is from 0 to 1 in that context, in the UV coordinates. And so once we just want that, we can just add that to our tile size. But tile is padding. I think I screwed up here. We take our tile padding and we divide it by our tile spreadsheet dimension. And if we go here, our tile padding is 2 pixels in comparison to our mtext width and mtext height. And we're sure this is called only after our sprite sheets have been rendered. So let's make a function. Let's make a function here. Let's call that load sprite sheet. It's gonna take in a SS path, the string view, and we're going to have it return nothing. I don't think we need to return anything. We do need to return the text data though. Text data needs to be returned. I don't know. We take in an SS path. We can also take in our text data. SS text data, SS text width, SS text height, and this text channel count. I don't think we need SS at the start, or maybe you can just remove the texture, just like that. And here, sorry, I didn't even TBI unsigned char. SS width must be int. Height must also be an int. Channel count must also be an int. And so here, okay, I can't directly include that, but I'll allow it. Here, we're basically going to do the same thing, except this is creating a texture and binding that to that. I'm not doing any of this. This is going to load the texture, and then we can free it later. So all it does is literally calls this. That's that. So load tile sprite sheet. I think I understand. So we have the SS data once, and then we don't need to do it again and again. But inside this text data, even like SS path, I'm gonna replace m underscore text with SS underscore. One too many underscores. We don't need to do that. Is that a problem? Our mtext path was a string view, and so we have to convert that to a C string. No member name C string and string view. Huh. You just taken with a reference. Whoops. Sorry. Yeah. So we take it in with a reference and then STBI load. So here we have the text data. Now if I load the tile sprite sheet, I'm going to put that inside, not text data. This will give a pointer. This will give an unsigned char pointer. So I'm just going to say this is an stbiuc, which is hopefully what we want, ss underscore data, unsigned char pointer. I'm just gonna do that. Unsigned char pointer. Unsigned char pointer. And so we pass in the pointer. And that's going to save it. I'm going to dereference that pointer. We give the memory address, and then I'm just going to directly save it to that. Because this returns a pointer. If this returns a pointer, I want to save it to a pointer. So this would be that. Yeah. We just directly pass in the pointer. I'm just going to save it. We have an stbi load, and now if it's a tile sprite sheet, we don't need to give in its width and height. Or actually, yeah, we can just do that. So we don't even need the tile sprite sheet. We can call load sprite sheet, and then just say, oh, that was tile sprite sheet path. And the SS data, this can be universal. We can just say SS data, and we can make that an unsigned char pointer SS data, and we can just pass that in directly. Then we have a width, tiles sprite sheet width. We want to put it in dimensions. We want to say dimensions dot xyz, right? Dot x, and I don't know. Can we directly add that as a pointer? Dot x. What will that do? plm vec2. Come on. This is a vec. If I use its x, will that be it? Okay, I'll just see if it works. File sprite sheet dimensions dot y, width and height. Then we're gonna have the channel count, which we don't care about. So we don't really care about that. Like that. So we can load sprite sheet type specifier as required for all declarations. What? No, I'm calling it. What? I'm not declaring it, I'm calling it. Load underscore sprite sheet. Oh, I can't call it an entity.8. Let's see if that's the case. Ugh. Entity.cpp. Okay, so when we're creating a tile class, I want to load that at the start. Like when we're initializing our things. How do I do this? Call function in header file. This is the lamest question I've ever asked. What? basically, why aren't you just directly loading it in? That's a good question. Why am I like doing all this? Why not just directly load it? sspath.cstring? No. Yes, maybe. File sprite sheet path.cstring. Uh, what? Oh, it's const expert. I'm gonna make it a const. Then RSS width file sprite sheet dimensions.x file sprite sheet dimension.y, and then this is gonna go to null pointer. What's this last one? Come on. Not showing it to me. Oh, the last one is just 0. Okay. X, Y, and then these two. Okay. Now that we have our SS data, then can I eagle out rename this to tile SS path, and this to tile SS width, and this to tile SS height, and this to tile SS dimensions, and I'm gonna say SS sprite sheet. Okay, so that should be cool now, because right off the bat we just loaded our sprite sheet, and now we have its data. I'm gonna take that and I'm gonna put it at the top. Now low key, you don't have to create a texture out of it every time. But why don't we just create a texture out of it? Like this entity class can hold this everything has a texture in this entity. If we're creating a texture out of that, what we're doing is we bind that texture, then we just bind it. Whenever we create it, we just bind it, binding it to that entity. But we can bind it, like we store it in our text. This is the main part. We just create a texture and store it there. So what if instead of having all of this separately, we just had a sprite sheet class? We could just have a sprite sheet class and then have singletons of them. No, and then we could have like a class sprite sheet, so we can just extend that. You know, because this seems lame as hell. Okay, let's try that actually. Let's create a class called sprite sheet. What happened? Create a class called sprite sheet, and here we can have its m underscore path. That's gonna be an std string, and then we can have a width and height. So rows and columns would be better. So you got rename file ss rows, file ss call. So we can have int rows and calls. We can put that in m, and then we can have a padding. So if that's the dimensions, how do I make this a vector 2? Like glm vec2 M. This is not rows and calls. This is what do you call rows and columns? Like, what are they? What are they? Collectively, records, fields. Like, I think if I call this dimension, and then this one can be file dimension, file dimensions, and file dimensions and file dimensions. So we can have that, and then we can have a padding, padding, but that's like file padding, and then we can have a m text unsigned int m text, and so inside this we can have a public write sheet, yes, and we can create the constructor, and inside our constructor we're going to pass in each of the important things, like we need a path, string view, we need a path, we also need the amount of rows and columns, that's an int rows and int columns. We would need, so file dimension is going to be automatic. File dimensions though, we need that. So file dimension, okay, then that we got that rows and columns, and so we just need file padding. So file padding, you have to give that to us. File padding x and file padding, or we can just file padding and then make that a glm vec2, and so we can put that here. So we can have we can say our m path is our path, and our m tile dimensions is rows and columns, and our m tile padding, file padding, might as well just tile dimension. Why not? Why keep them mixed up? And then we finally have a text, and then the texture, and we also have the file dimension. So we're going to take that. What we're going to do collectively is just copy whatever this entity has, cut it absolutely, and then paste it here. So we're going to take the text data, we're going to free the text data, and m text path, so this is texture path. We're just going to, within this, if we find an m text path, we're going to take an ss path. Oh, sorry, an m path. So this is the m text width and height. So here we can say m tile dimensions dot x, m tile dimensions dot y. Sorry, width. What do you call it? File dimension. File dimensions dot x and file dimensions dot y. Then we have an m text channel count. So since we're setting that here, I think making that const is fine. Not a constant expression. Const, and even the path. Yeah, because once you've created a sprite sheet, why do you even need to change the tile dimension? But okay, let's just allow that. Maybe there's a chance. M text channel count. Like, nobody asked for that, but I'm still gonna keep it. I'm gonna say there's a channel count, m channel count, and I'm gonna set that go to nothing, and here I'm gonna set that m channel count. So we're having STBI here, and then here we Don't need mtext width. We can just say mfile dimensions.x, mfile dimensions.y, just like that. So we just create it and then we can just bind it easily. We can just bind that texture. You can even do something like public, like bind texture or bind, and that's going to be void. And here we can just straight up bind that texture. Isn't that cool? And now all of that burden is off from the entity. The entity just needs a sprite sheet. Does it need a sprite sheet? Does it need a sprite sheet? So we're gonna have a sprite sheet pointer, or it's just sprite sheet reference. Sprite sheet reference. Sprite sheet reference SS. And here after tile type, or just before tile type, do we need to reference the sprite sheet every time? Is that even necessary? Because we give that to entity just so that it could bind it and store it. We don't actually need it. Right? We can just bind the sprite sheet and we'll automatically find out the X and Y in the tile type. But it will always need to bind that. So do we like take in the sprite sheet and then let it bind it for us? The sprite sheet reference SS. It will take that in. For entity is gonna put in X and Y, and we're gonna change entity to like ignore all that. We're gonna change entity to ignore all that. We don't need the text path anymore. We don't need the texture path. You don't need to pass it in here. You don't need to have these protected variables. You don't even need this. And you don't even need this. Nor do you need this. Look at that. We don't need to get text path or that. None of that. And all that's left here is tile SS dimensions. Instead of setting them up here, we already have them. And all that's needed is to bind that. Before we're trying to create anything, we want to bind our tile before we render them. But that's stupid again. We don't really need to bind them to create them, so technically we don't even need all of this. Look at that beauty. So. We don't need to pass in a text path here. We need to pass in a text path here. We do not need to pass in a text path here. So yeah, if you have a sprite sheet with only one sprite, then you can just say that's the 1x1 row and column, and you can say that, and we'll automatically get it for you. So we don't need the text path here, and we don't even need it here. Okay, everything about textures is like completely separated. We don't need to do all of this. And now we can have a simple sprite sheet tile SS. And let's just see that. So let's just make that auto. Tile SS is equal to sprite sheet. Why is it giving me that? Why is this giving me candidate constructor? If I remove the R, is this like fixed? Yeah, which means sprite sheet is already something. What do I name this? I name this SS. That's the worst name ever. Maybe sprite sheet, just like that. So sprite with an S capital and both capital, so sprite sheet, and we can start that off. But of course we need, oh my god, let me drink water. In our sprite sheet, we need a path, some dimensions, and a padding. So we have our path right here. Path right here. Then we have our dimensions. So our tile dimensions can be 12, 13. And our tile padding can be 2, 2. And that's it. We don't need any of this. All of that's gone. And now the only thing we needed was SS data, but that's also gone. Means nothing is left. Let's go. That's cool. Any.cpp, no need. We have a single SS file. Okay, now we need to change wherever there was a sprite sheet. So let's just see where the errors are. Here we're trying to get the texture from our tile. So we're not going to do that. We're just going to say every time we want to do that, we're going to say SS our tile SS dot bind, and that's enough. Once we've bound our tile sprite sheet, Sprital SS height. What the hell is this? What did it do? What have we done here? Our tile SS count is literally just our tile SS dot dimension. So tile SS dot. Oh, I need to make some getters. Let me make some getters. Let's see if I can do this like. Okay. We're going to this unsigned int is messing me up. I'm just gonna take that out and put it here. And now I'm going to do this. How do I select the type? Okay, anyways. We're just going to, okay, I know. I'm going to line. Yeah, just like that. And then I can simply go ahead, make these getters. Make these functions like this. And inside here, make some spaces and return all that there, m underscore that, semicolon space. It's done. There we go. But we still needed an unsigned int mtext. We can get x, return mtext, and there we go. We have that return. So we can directly, for SS count, we can say tile, get tile dimensions. And for SS index, that's All right. Here we have a tile SS index map. Tile SS index map. Yeah, that's stupid. So we're gonna have a tile type, and then we're gonna move both of these inside. Look, if we have a tile, then we can have a tile type, and then we can map those to specific indices. But that depends on the sprite sheet. There must be a map of a specific enum, which means I can make this templated class of an enum class type type T, right? Type, and then that's it. Now what's happening, right? What's your provider? So we have a sprite sheet with our type, and so what's going to happen is we're going to have an M map, which is going to be an M map, which is going to be an SPD map from our type to uh to an index. Yeah, to a GLM vec2. We're gonna do that. And not only can we get in this, but we can also set it. So get text, so get map, M map, but we can also set it. So we can set the map to, I'm taking a map val, a map to val. Can take that. So this map must be of type T2. T to what type? So we can take the enum class on one, and then we can have save GLM vec2 on the other. This is a void set map. So through this, we can easily set our map. Why is this complaining? Because I'm being goofy. Just like that. And now we can simply set our map through this cool interface. So let's okay, whatever. Here in our sprite sheet, we can include that this was our tile type, and that's it. So when we're having our tile type here, we can do this. What's happened? Enum type, enum class, template argument for non-template type. Template argument for non-type template parameter must be an expression. C++ template enum class. Type name T. Oh, I have to do enum class. Type name enum class, and then enum class enum val. Have a normal weak enumeration user enumerate devices non-type template parameter. Do we just do a type name T? Enum template to be an enum, yeah, to be an enum class. Concept finally come out. There's hoping for next year. I don't think that's 10 years ago. But we can include type paired. Enable if that value. Then we can also static assert. What's this? Enable if P is enum. We just add that there. tile padding and everything is showing errors, but we're gonna look at that later. So we have a tile type, and then for each tile type, we're gonna have this. So instead of this being our whatever, we're gonna say, we can easily just say tile underscore ss dot set map to be whatever this is. What? Revert buffer? Okay. No? Unknown type name tile ss. You're saying you don't know what tile ss is? We have a set map here, but you don't know what tile ss is. Unknown type name tile ss. Why would you say that? And you cannot use dot operator on a type. Why does it think this is a type? Okay, let me try one thing. I'm gonna put entity.cvp. I'll put this here. I'll also put this here. And I'm going to hash include entity.h. Redefinition of tile dot. Not tile ss dot bind. If in our CPP file we are declaring that, okay, if I do this, okay, tile ss is not found. We don't know what tile ss is, but it's still saying even here it says unknown type name tile ss. Why is it an unknown type? Spreadsheet file type. Happy? What the hell did I just do? Image free text data. And then we have that right there. What's wrong? Tile ss does not name a type. C++ does not name a type. Oh, sorry. Hashtag pragma once. This type. If we have a template class sprite sheet right over here, okay, so maybe I have absolutely no idea. Class user and gets to the message box. Message has not yet been finding where is not yet. But the sprite sheet class has already existed. Oh, but I think this is in a header file. So templates. C++ is not name a type. Templates. I think templates and header files. Templates and header files won't matter. I'm gonna have to create something. So create header file. forward declare class C++. Here we're doing something, and then we can just implement the method to declare a member variable or as a base class button use a full determination. Someone to use forward declarations. From a design perspective, use forward declaration reduce coupling between class. That is, a class A depends on class A doesn't need to know the size of B. Okay. Also, manually writing the forward declaration in line where it's needed can be problematic or downright cumbersome to read. What? Also, manually writing the forward declaration in line, and thus it's recommended to use a .forward HTTP. What? That's crazy. Templates in initializing templates in header file ensures that the complete template code is visible, but only be implemented in the header file. And then if you're implementing the header, let's see the alternate solution at the end of any way the reason you're coding failing that when you finish the header file. It creates a new class with the given. Alright, consequently, one needs to have access to the implementation of the methods to instantiate them with the template argument. Int if these implementations were not in the header, it wouldn't be accessible, and therefore the compiler wouldn't be able to instantiate the template. What I'm thinking right now is here when SS does not name a type, there's no way that that's just normal. So if, like, for example, if I say tile type, let's just say I create a tile t is equal to new tile 0 0, and then I'm going to say this is a tile type grass temp, and then if I tile dot wait a second. Um, when we can get the type t dot get type. Yeah, so that's not the error. Mm, unless we have like a map set in here. Can we call another constructor from this one? Okay, we can do that. So if I just sprite sheet, oh, is that necessary? I don't think so. We can get all of these, and then we can also get a map. We can also get an std map of our type and a glmvec2, which can map all of our tiles to our indices. So map. What this is going to do is it's going to call the other sprite sheet constructor, where we're just going to directly pass in our path, our tile dimensions, our tile padding, our map. Okay, now for map, we're just going to set our map here. So we can say we can directly put into our map m underscore map can be equivalent to map, and that's it. So I can directly put that in the constructor, so I don't need to do any amount of. There we go. What is it saying now? An instantiation member function. What? Or this follows constructor delegation. Okay, so it must not follow constructor delegation, which means it must be behind. So here you can just do that. No. Did I not put it in fully? Path, file dimensions, file padding. Constructor delegation follows memory initializer. Member initializer. Oh. We can use a member initializer, including all members. We can work on this by defining the version of the constructor that takes the argument first, and then define the default constructor using delegation. So you're going to say tokenizer with a null pointer with an empty value. Okay, so we're assuming a map ta, and that's what changed it. So we can just take this entire thing, plop it at the end of file padding, and then here we can just say m map is just map, just like that. However, here we're just gonna not take in the argument and then just use normal constructor delegation, and then where it asks for a map, we're just going to say something like empty or empty initialize a map. Maybe I can just do that. Yep. So that should, oh, thank God. Okay. So all of that's gone. Initialization argument of USBIC is taking this. Yeah, as I thought, that the int pointer x, there's a point problem. Oh, that takes an int pointer x. Can our vec2 is a type alias for what? For vec2 comma float. Is there like a glm vec2 integers? Yeah, these vec2s. That's so annoying. Okay, maybe I can convert this into an int pointer and then or take the memory address of that and then convert that to an int pointer. Yeah, that feels really illegal. But we're gonna go with it. Energy.cp can be removed. So instead of our index map, we can just say ss tile ss dot get map, and we can get our tile type, and then we can get our tile ss dot padding, get tile padding, and our dimension tile ss dimensions, get file dimension. That should be everything. But I really, yeah, segmentation flow. This is the error. Like, you can't just do this. What I think I'm gonna have to do is template length. Okay. GLM, can I get a pointer, value pointer? What is value pointer gonna do? I'm gonna take this. Value pointer. This is going after taking it to any type, and then returning the memory address of v.x. But that takes in like a what does this return? This returns a GLM func qualifier. Oh, T pointer. So pointer of the first type. I think I'm gonna have to do something goofy like file dimensions, or I'm gonna have to create like an intermediary here. So two okay, vec2 file dimensions glm glm vec with a length tl and a type name t. So 2, and the type name is an integer, right? Now can I just give the value pointer of our x? So that got the value pointer of our x. Dot x. Then if I wanted to get dot y, which means it's consecutive, like it's one after the other. It's contiguous in memory. As segmentation works, it all boils down to this line. Can't just do this. GLM value pointer. GLM get int pointer or vector. Okay, I think I have an idea. What we can do is just create an int width and height. Then go ahead and in here we can just reference width and reference height. So now it's going to store it in those integer variables. And all we have to do now, and we don't need to do this anymore. Do we? Do we not? Maybe. Let's try if we can do it with an integer vector. That would be cool. If not, that's fine too. Vector to int and yeah, glm vec. Width and height. So I think I can just do this. Width, height. That's cool. I think that's cool. So, but there's still segmentation fault. And now I'm starting to think it isn't the problem with this. I'm slowly starting to think not even really a problem for this. So M file dimensions with S2 float. Oh no. Oh no. Why? Did everything correctly. I didn't. Let's see. Anyways. Oh my god. If we load this into our width and height once, and then we can bind it easily, every time we can bind it with this, we can always get a map and then set him. This. We can have different types. We can even create the entities and characters and a player. What's the problem? Maybe if we don't free it every time? Ugh. Why am I getting a segmentation fault? I do not want to go into the GDB right now. But you know what I'm gonna do instead? If I'm taking empath as a for oh maybe it's with this. Can I like do that? Maybe I can just make a new STD map, you know, with type and a uh type and a vec2 PLM vec2 like that. Why is it gotta be why? Oh no, that doesn't make any sense. I'm probably doing something wrong with the STBI. Let's say I don't initialize anything, I don't bind anything. I'm just gonna gen a texture and that's it. No. What? It's probably here. Once we've created the bruh, why is there gotta be segmentation code? Okay. Let's GDB. I've forgotten how to use GDB. Files running the program. Help running. I'm gonna have to put inside our make file. What was that, like a debug level? G++ debug level. Dash G. You can use debug information optimization O3, but the information is poor sometimes. Strip the debug information is the trade-off between fast and small. O3 means fast. OS means as fast as possible without increasing the size. Dash G3. So dash G3. So R cross slash Okay, maybe if I quit gdb./a.out, run, segmentation fault stack, help stack, frame, so we don't know anything, frame view, backspace. Okay, in sprite sheet where we pass in effect2 with a GLM qualifier 0 allocator and everything. So it's inside that. It's absolutely inside that. So let's go to entity.h. Now, once we've done this, then how can there be an error now? That doesn't make any sense. Is it because we're taking mpath, mtau dimensions, mtau padding? Let's remove map from our equation right now. Let's completely remove the map from our equation. Let's just say we never had the map. We never had a map. We never had this. This is unnecessary. And anything to do with map. Not with maps, but yeah. We don't need to set or get map. I mean, you can. Not in the constructor though. Same thing with here. Right? What? Like that. Nothing's wrong now? It's still segment. It's still a segmentation fault. And it's still inside that? How? Why? Segmentation fault. You understand how that makes absolutely zero sense. A segmentation fault. How are you just gonna put down, back up, put down a segmentation fault? You know what? At least I got here. Right? Come on. I believe in you. IO stream. Oh? Did you mean... Okay, since we don't have the map, I hope I didn't just absolutely just delete that. Okay, I did. I'm gonna have to go back to where I did have this. I'm gonna go all the way to the end. and I'm gonna paste that right into file SS. I'm gonna paste that in common like that. I'm gonna make this equivalent to, let's just see, auto, let's just say tile map. Can I not do this? Cannot deduce actual type from tile map from auto, okay? For some reason it can't. Tile type and PLM vector. All because of this. Okay, so we have our tile map now. And so instead of getting the map, let's do a tile map. Please, 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 please don't segment. Please don't. Ah. It didn't even get here. Oh no, at least I got here. Okay. And then here. And then one after we've done everything. And then one when we free it. It got to two of those. Which means there's no problem with width and height. There's no problem with anything else. But there's a problem with the third one. When we're trying to put something into MTech. Yeah. It's the problem with generating a texture. Gen textures throws a sec fault. Oh. Okay. That makes sense. That makes sense. That totally makes sense. We'd never set up OpenGL when we're trying to generate some textures. So of course it's gonna bug out. None of it's gonna work. Okay. I get it now. Once we've done all of this, and file dimensions and everything, we do inline and then we don't even need to do this. Like that. I don't know why it gotta be goofy like that, but okay. So I can't really create a sprite sheet here. I have to create it in main.cpp. I'm gonna create a sprite sheet after we have a valid context and everything. So before creating anything, here. So here we're going to make nn.out. File map is not declared because file ss.get map second. Okay, it's finally working. It's finally working. Let's go. Our sprite sheet was loaded successfully. Isn't that beautiful? I think that's pretty poggers. That's pretty poggers. I'm gonna do some fill my water and be back. I'm back. I'm back. Okay. Where were we? So we finally implemented our sprite sheet, a sprite sheet class, and now we can have cool tiles. Look at that. Look at that. We have two cool tiles, but I don't think they're actually working. We did a grass M and a dirt M, and we took that from our map here, over here. But I think that's, yeah, 7, 9, 7, 8. But it defaulted to 0, 0. Unless I'm multiplying something wrong. Our tile size might be 0, which means our tile SS count might be 0. So if any of these things 0, what could be the problem? Let's see. So we have tile dimensions, which is 12 by 13. And what? Why is there a bar to the right? Oh, that accidental command. Okay. Um, we have 12, 13 for our tile dimensions, and then 2, 2 for our tile padding. Both of these are initialized vectors. We can make them and dot slash a dot out. That's a lie. Our grass R is that. Our grass M is that. Our grass L is that. I think we can include this as a map in our header file. Here in our tile types, we can also just put this. We can just say this is a const std map of our tile type and a glm deck2, and we can call this tile map, right? But in like all cap, tile map, and then here we can just tile map that out, you know. Let's just see. Boom. I don't think that will make a difference. And here we go. What is going on? Oh, just did not put a semicolon in. Start squeaking out. Okay, it's working now. The problem is it's not working how I intended it to be, you know? At least it's not a seg fault, but it's still annoying, you know? Because I changed none of the maps, which means there must be an issue inside here. Okay, int width and height. I say m file dimensions is width and height. Here we take that. We take the tile dimensions. We save them exactly there. Then we do this. Then all we have to do is bind the texture. So unless get tile padding divided by get file dimensions, here we're tile dot get map, and then we're getting tiles dot type, our current tiles type. Then here we're doing something different. Here we're getting the value pointer of our tile dimension, saving that in SS count. Something seems wrong. Tile scale. Okay, that's normal. That's so weird. And tile SS dot bind. This one's a grass M and this one's a dirt M. They're completely different types. Yeah, I can't think of something that would change our output to a completely different texture within the same sprite sheet. Like, you know, kind of sounds goofy. Look, if we have a tile map, and that map, what is that map telling us? Let's go to that. What is our map telling us right now? What is our map telling us? So unless we have our m file dimensions.x, m file dimensions.y, and then we're converting them to integers like that. Loki, I don't know. It's at 0, 0. You know what that leads me to believe? It leads me to believe that either sum of this is 0, right? Either tile dimensions is 0 or something. So you know what I'm gonna do? For each tile, every time we're about to render, I'm going to completely print. I'm gonna print the entire tile SS. CD out tile SS. Can we even do that? No, we can't. Of course we can't. So instead, we're gonna have to print it, get tile dimensions, and then tile ss dot get tile ss dot get tile padding, and last but definitely not the least, this is actually the main part. It's tile ss dot tile map, or just tile map. Sorry. Yeah, but tile underscore ss dot get tile map. Now, why is it crying? I think because we have IO stream, we don't need O stream. What's going on here? Why is it freaking out? Oh, GLM vector. Okay, that's kind of sad. So dot x and then dot y, and then here we're gonna do the same thing. Guys dot get tile padding dot x, and then we're gonna have to have a space. Tile ss dot get tile padding dot y, and here we're gonna get the map, but we can't just print the map. So I'm gonna get the map at tile type dirt m, right? Because dirt m is something we're printing. Oh, but it's still still a vec2, so we're gonna have to manually print its x and y's. We're gonna print its x, and we're gonna manually print its y. This seems like an epic waste of time, but let me try it. Let me try it. Let me at least try. Let me try to figure this out. Okay. It says 12. It says 12, 13. That's correct. It says 2, 2. And aha. Here it says 0, 0. It says, look at that. Look at that. It wasn't a complete waste of time. It says get map. We get its dirt m. Here we get its map. We're setting it to tile map, and you know what's happening is I didn't even properly do it. I think I didn't even. Oh my god. Okay. Okay. But I think that's because that's crazy. I think that's because we're adding some padding mats to it. Let's just remove that completely. Mi amor, mi amor, mi amor. Let's go. Isn't that beautiful? I think that's absolutely bonkers. That's so amazing. We want to minus it from our padding, but that padding's too big. Yeah, the padding's like the U tile, SS padding. Something's going on with that padding. What we do is we get the tile padding, and then we divide it by our file dimension. So if we have 2, yeah. So if we have 2 upon like whatever that must have been, that's gonna give you a number. What number is that gonna give you? Shouldn't it be from 0 to 1? So like 1 upon all that, like that. Okay. We say 1 upon 13, right? Because it's like, oh, Let me get that. Our tile size is 1 upon 13. Let's just say, for sake of argument. And then, and we're only talking about the width. Then what we're doing is we jump by those tile size. Okay, now we have that. How much do we want our text port to contribute? Then we usually do tile size, right? Which is just the amount of tile. But instead of that, oh, we want to do this at the end. We want to do this at the end. We are not changing tile size directly, yeah. And now it hasn't really gone. I can't really zoom in on that, but it's like maybe if I change the tile scale, we can see it too. Instead of that, I'm gonna say 1.7. I'm gonna see what I'm talking about. Yeah, you see this on the right hand side. It's getting some of that as well. Kind of goofy, low key. That's very goofy. And I'm gonna say 1.5 so that everybody can see. Yeah, I hope you can see that line even with the compression. Means all we're doing is we're taking that from our FX port. No. I see. So that's why I was putting it inside here. Because we're saying, okay, take our text port, multiply it by our tile size, and tile size should be something from 0 to 1. And so should tile SS padding. I think I got it. It's how much of no. Uh what's happening? So let's just go here. Let's just go back to our thing. And so at the end, so each of our blocks, each of our tiles has like this much padding, right? This much padding. It's like 2 here. This is 2, and this is also 2. And this is 70, and this is 70. So what we're saying is, if we have many more of these, right? We have tile size. Can we just get the tile count? So what we're currently doing is we're multiplying our texture coordinate by our tile size, right? So we're taking our texture coordinate, multiplying it by our 70 pixels or 72 pixels. So we jump 72 pixels every time. We want to jump with the paddings. That's cool. But when we get to that point, we don't actually want this. So our tile count, 1 upon tile count, will split our thing, which will split our file exactly into 13 blocks. But I want to reduce just a bit from that. I just want to reduce a bit from the tile size. How much will that be? That will be our. How much will that be? How much do we want to reduce from our tile size? How much do we want to reduce from our tile size? How much do we want to reduce from our tile size? That's 2 pixels. And what's 2 pixels equivalent to? In our file. Throughout our entire file, that would be like yeah. So that would be the padding in pixels. Padding in pixels divided by our total file width, right? That will give all of those. And then we're going to take that and divide that by our tile size. I think I found it out, but it's supposed to be in here. I'm going to flip them again. But this time, I'm going to divide that by tile size. What? Okay, let's just see. So we're gonna take 2 pixels out of the, I don't know how many. Let's just get the file. This one. We're gonna get 864 by 936. Okay, because we just removed the column, nothing different. We get 936 divided by 2. That's something. 2 upon 936. That's like, okay, we have, that is the bit of portion from our entire file. And then we're going to divide by, 13, right? Because we have 13 columns. And then now we're going to subtract that. We're going to subtract that teeny tiny amount from our tile size. Because what was our tile size? It was 1.0 upon 13. Right? Because you know why? Because when we can multiply that by 13, and then we can get 1. Yeah, this is actually, it should completely work because we're taking the tile size and we're subtracting our padding upon our tile size. We get the padding, we get the proportion of padding, and then we just divide by tile size. Okay, you know what I'm gonna do? I'm just gonna reduce manually. I'm gonna manually see how much. That didn't do anything. That did quite a lot. That didn't do much. But if I'm doing this, you see that's completely removed that all. So what I want is 2 upon the width. Sir, how are you? Assalamu alaikum. I'm fine. Just trying to make this spreadsheet work. I've basically done all of the boilerplate. So the shader has got some important mathematics. So I have, what I have done is I've made an entire spreadsheet class, right? An entire spreadsheet class, and let me show you how that looks. I've changed the spreadsheet a bit. I've run into some bugs because the spreadsheet wasn't made correctly. Tried to do some of that. Then, since this is 13 on the X and on the Y and 12 on the X, I had to then make like a tile class. So this spreadsheet was templated with a type. It can take in any specific type, and then it can map that to a specific index. For example, here when I create an instance, I'm creating an enum class tile type, so we can have a grass middle, grass left, grass right, and a dirt middle. And then we can create a map which corresponds to which index it is on. So if I go here and if I count from the left, 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, right? Yeah, 7, and then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to get me the grass right. I think I miscounted it, but yeah. So likewise for ML and dirt middle. Then what's left is a public entity. Yeah, so I created an entity type, which, I created a tile type, and then a character and a player. So it's all simple, nothing different. The tile just has a type. Then all I've done here is in the spreadsheet, I've just loaded using STBI, and then I've created textures from it. So I have to only load in the spreadsheet once. Whereas before we had every time we created an entity, we had to generate textures again and again. So that would waste memory and time and performance and everything. So uh, yeah, the important part is all of this. Where using vectors, I had to figure out um, map the UV coordinates. So our UV coordinates from 0 to 1, right, or the S&T coordinates from 0 to 1, I had to map them to this. So I had to find, okay, if I have something at 2 and 3, or at 3 and 2, how do I get the decimal representation of this specific point, of this specific point, of this specific point, of this specific point? So there are multiple ways of doing it, but I think I found a really elegant solution. And that was to say, get the text code. So all our text code data is in 1.0, 0.0. So if you go into the vertices vector, all of our the text coordinates are from 1.0 to 0.0, right? So I thought, what if we just added to that a certain amount, and then we just multiplied every 1.0. So instead of 1.0, it's going to be multiplied by some amount to bring it back to like this. So basically, the main gist of it is I ended up doing that. Since all of these are vec2s, I can just divide them and then multiply through them. So I got the tile size by taking 1 upon the amount of rows or columns. And so I got the amount of the tile width and tile height. Then I took the tile size times index. So I've got a tile size, let's say it's 70 pixels, which in this case it is, but with 2 pixel padding. So if I have 72 pixels, I'm going to jump 72 pixels, then 72 pixels, then 72 pixels. How many times? 3 times, because I'm skipping 3. And then we're going to add ftext times our, ignore this, ftext times our tile size, which means our text coordinate should be 1.0 or 0.0. If it's 0.0, we're just going to stay there. So that's our point. That's our point. But if we wanted 1.0, how much should it stretch? It should stretch tile size. Right? So instead of 1.0, it's going to be scaled back to just a simple tile size. And we're just going to add that to this point, and we're going to get the 4 points from our 0 to 1 scale. The problem with this is that even though I got it working, sorry, and I also figured out the tile size. Here I can take a tile scale and everything. You can see the stream what I'll upload on YouTube. At the near the end, I just recap and explain the maths. But tile scale, I'm gonna take that to 0.3 right now, and now I can exactly pair up the points. But you see, they're not really touching. They're not touching because there's a padding for every one of these. Let me show you. So you can see that there's a 2 pixel padding here and a 2 pixel padding here, but it's not on. It's not here. It's not on the left and top, but it's on the bottom of every tile and on the right of every tile. Not on the left. It's not on the top. That's the bottom of this. So how do you calculate that? That's a pretty good question, and that's what I'm trying to figure out. So my solution to this was creating a uniform, creating a tile SS padding, where I take the padding pixels per tile, which is 2, and dividing it by the total pixels of the image. So we got all the padding pixels on a scale from 0 to 1. So that's what I was doing. I was trying to figure out. So I got 2 upon 936. If I run the file command, I can see its resolution. And it's 864 plus 72 is 936. So this is the same, the square, but I've just removed one column from the rightmost side of the sprite sheet. So if I take 936 and divide it by 2, 2 upon 936, that will give me the proportion, the percentage from 0 to 1. That will give me the scale of the padding. But that's for all of the paddings combined. No, that's a single padding. That's a single padding. 2 upon 936, that's a single padding. So I can just directly subtract it from the tile size. And if I go to padding, I can get the tile padding and divide it by the file dimension. Why is it dimensions and paddings? Because the padding might be different on the X and it could be different on the Y. So that's why it's a vector, two vectors. This is equivalent to saying get tile padding dot X, get divided by get file dimensions dot X, and then for the Y, get tile padding dot Y divided by, but this is a shorthand. And what I'm doing is every time I want to render it, I'm just gonna loop over the tiles vector, and then I'm just gonna get its positions, scale them, and so that I can just simply write my positions from 0 to 1. So all of this is just get it from 0 to 1, and the orthogonal matrix, this one, is so that it stays a square. That's about it. What are we doing here? So right, but the problem is every time I try to run this, that's what happens, and I don't understand that. Oh my god! I've been supplying, I've been setting SS padding, and for SS padding uniform location, I've been supplying SS index. If this works. Oh my god. Bruh. That took too much time. So stupid, bro. Anyways, in summary, all we have to do now is just do this. Tiles.inplace back. I just add this to the vector. We're gonna specify the x and y, and then specify its type. We can say grass m and then dirt m, and then all that's going to do is going to handle everything for us, the sprite sheet, everything, and it's gonna render out 2 of these. The good thing with this is I can also have clear animation and everything from the class, from the sprite sheet class, so that's going to help. But yeah, what next? I think we should move on to the this entity.h. Just a second. Okay, so what's left is implementing the levels class, and that's just going to be a 2D array, so it's going to be a vector by vector, and then you can just specify different tile type. You can specify tile type, tile type, tile type, tile type, and it's going to create a level, and from that, I can just render it automatically. The problem is, I just need a 2-minute break because I've been doing this for some time. Not right now, but I also have to do something else. Gotta go. Okay. Let me just put on interrupt. I'm back. I'm back. Sorry if I scared you, but I'm back. Let's make a level. Let's make a level. Do we want to make a level first? I think I want to make a level first. Level.h. Oh, I've made this already. Okay, class level. Inside this class level, what is going to happen? I mean, do we even need to do this? Like, we don't even need a separate class. But there could be multiple levels. So we can just store them as an array of arrays. I don't even. I don't really need a class right now. I'm going to comment this out, and I'm going to just specify them over here. So let's just say level 1. Okay, level 1. That's a constant. Level 1, and we can what's its type going to be? I think std vector of std vector going to be a vector of vector of a vector's type is tile type. Low key, this could just be an entity.h. I would prefer that actually. Just below tile type, level 1. We don't even need this. And we need to include vectors. So hash include vectors right here. So this level is going to consist of, but honestly, it should be the same length. Should it be the same length? No, it shouldn't. It doesn't have to be. Okay, I have an even better idea. So which header file are you writing now? Which header file I'm writing now? I'm writing entity.h. This basically, for now, it just holds everything I need, all the classes and everything. I am going to separate it out a bit later, but right now I'm thinking of how to implement the level. So what I'm thinking right now is if I just have a picture of pixels, and then depending on the color of those pixels, I can read the file in pixels, then check each type, each color, and then map that to a type. But honestly, I don't want to do that because I would have to specify multiple colors, and then do I want to do it? I don't think I want to do this. What do you think, Seb? What should we do? Should we read it from an image or just manually do it through vectors? For now, I'm just going to manually do it through vectors. So let's just say we have a wall. Okay. 1, 2, 3. So 1, 2, and 3, 4. And right here at the bottom, at the fifth one, or actually at the fifth one here, I'm going to specify multiple tile types. So tile type dirt M, or just grass left, and then multiple of the grass middle, and then just a single grass right. Sorry, that's off the screen right there, but I think you can see that I have a right at the end. So how we're going to do this, we would need an air tile too. Yeah, because how else? I don't think so. Yeah, because how would we separate something from here in the same row? So there needs to be like an empty, empty, or none, or empty, none. tile type none, and what's gonna happen here is let's just try that out. So left and then right and then tile type none. There you go. So we have two blocks at the left, and then a gap, and then a line of blocks. So it's basically I'm creating a floor. This level is just very simple. And then let's see. Once we have this none tile type, however, I need to map it to some texture. Oh, and because our sprite sheet has empty, I can just map it to this last corner. So I'm going to move to tile map right over here. And I'm going to say that that's completely at the end. And this is none. And since it starts at 0, I'm going to do 12, 12 instead of 13, 13. Or 12, 11. 0, oh my god, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Okay. So we have our none at this. And I'm going to put this none at the very end of our tile type enum class. Isn't that cool? Isn't that pogger? Let's go ahead to our main.cpp. And instead of doing this goofy in place back and all of this, all I have to do now is I can have this tiles vector, and then I'm going to loop through our levels. So I'm going to loop through our level 1. So for tile in tiles, but notice how tiles is a tile, and so it can automatically figure out that just it's a tile. I don't have to type it again because that sounds weird. So for auto tile in tiles, I'm just going to do one of those. One of these. Oh, sorry, what am I doing? For auto tile in level 1. But even that doesn't make any sense. So for it's an std vector of tile type. Or level 1, that is. How have I named it? Yeah, level 1. So level _1. My eglots. Okay. Are you okay now? It's throwing errors everywhere. This will be what? This will be a row. And then for each row, we're gonna have we're going to have a tile type. Oh, can you just tell me about enum class and what is meant by num? Is it a tile name from a tile file? And why does it not need a type? I mean data type. What? Can you just tell me about enum class and what is meant by num? Where are you reading NUM num? Oh, what is meant by enum? Okay. Yeah, I was just a bit late. Nay. You have to apologize right now. 10 times. I'm joking. Can you just tell me about enum class and what is meant by num? So look, in enum classes, right now, you just have a group of names that you want to store. You could store them in an array, but you just want it to be not indexed. You don't care if it's indexed. You just need to see it should be one of these, I can't just turn out and say tile type dot, if it's a class or an array, I can't just go, 29. Or if it's a map, I can't just go, you know, um, like ferns. I can't do that. It needs to be, if I do that, it will give me a compilation error. Look, I can't do this, fern. It will say no type named fern and tile type, right? But if I say grass R, it limits my option. It's like, oh, yeah, grass R is one of the, sorry, that was a different error, but my point still holds. This is now only possible. Okay, do you understand the general gist of an enum? Basically, an enum and enum class is not that different. There are slight quirks. You can learn that on learncpp.com, but you generally understand. Hope you do. So for tile type, and this is a column in row, right? So our level is made up of vectors of tile type and then vectors of that. So we have a row and then we have a column. So we're going to get the vectors of tile type, this, for each of that row in our level 1, and then we're going to move through each of our tile type column in that row. So we're going to go basically, I'm going to flip it on your webcam so you can see. Basically, it's going to be duck, 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 and then it's going to go down here, and tuck, 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 just like that. Okay? So we're going to tiles.inplace back, and then all we want really is an index. We also want an index. Now, the unfortunate thing is C++ enumeration in for each loop, right? Not iterating it over in enum. Oh, like counter get index in for each loop. The problem with this is why isn't it showing me that? Not showing me that. Basically, in C++20, what you can do is do something like this: enumerate or enumerate std views well, please, enumeration view. This one. You can do this: std views enumerate on your v. Forget this pipe symbol. Don't worry about it too much. And then that's going to give you your index and then your element as well, separate. The problem with that is it was removed in I think, let's just look at that. It was removed at first in a small version, and then now it's completely here in C++23. But that's in C++23, and we're not using C++23. That's like, that was released in 2023. So instead, we're just going to be losers and manage our row index ourselves. So we can say int I is equal to 0, right? And then int j is equal to 0. And then I could do both of those at once. I is equal to 0, j is equal to 0. Just a second. Okay. So int I is equal to 0, j is equal to 0, and here every time. Okay, my brain's lagging a bit, but what were we doing? Yeah, at the end we want to do I++, and at the end of each row we want to do j++. We could also just manually do this. Like, instead of this, we could just say for std vector, like for int I is equal to 0, and then I is less than row dot length, level 1 dot length, and then I++, sorry, dot size, and then I++, and we don't have to do this. Yeah, I think that's better, because we can just directly use the level underscore 1 at I add j, just like that. That would be much better. And so for int j is equal to 0. J is less than no, fine. Level underscore 1 at I dot size. J plus plus. Yep. And now we can say what type would it be? It would be level underscore 1 at I at J. So we can just get the at I, get the J, and then we can get the tile type. But what is it X and Y going to be? It's tile width times I. Actually times J, and then times I here. Because that's our row. So if our I is row, that's our Y. And our X is our J, our column. Yeah. That should be good. Let's see. Tile map was not declared. What happened to tile map? Did I forget a semicolon? I did, in fact, forget a semicolon. Whoa, look at that. Look at that. Look at that. Look at that. Pretty cool. Why is there a crate in the middle? That's a pretty good question. Okay. At least that's something, yo. Um, at least that's something. One thing, though, is that this needs to be times j plus 1. That needs to be true. Oh, the none. That was the none. Yeah, never mind. That was the none. I screwed up the coordinates, maybe. Why is it only showing half of that? Okay, which means I need to do like plus tile width divided by 2 plus tile width divided by 2. Yeah, woo, let's go. I know, right? That was a bit late, but woo. Okay, so now we have it at 0, 0, and now it's going there. So it left 1, 2, 3, and 4 tile widths, and at the 5th column, it did this. I am going to make a camera and center it and everything, but forget about that right now. We're gonna figure out this none, and the left and right, I got that reversed. The left and right is reversed. The left and right is reversed. So it's the MLR. So the M, L, R, and let's see where that is. So the middle is in 1, 2, 3, 4. Sorry, let me bring that up. 1, 2, 3, 4, 5, 6, 7. Seven. Because it's like a grass tile, it's like a simple grass tile. Like I didn't need to choose that tile, but you know. So then we have 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the correct middle tile. Yeah, middle tile is correct. The left is 7 by 7. The left is 7 by 7. Since this was 7, going up is right. Yeah, so I did an oopsie daisies. No, yeah, that should be 7. That should be 9. And the none is supposed to be 12, 11, but it got this somehow. Or yeah, it got this. How? How has it gotten that? Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh. Yay, let's go. Okay, I see that there are gaps in the middle of these tiles. We can fix that, but we have this random middle tile floating in the middle of nowhere. This should be elective. Look at that. That's nice. Now I understand. Thank you. Look at that. That's beautiful. Now these tile gaps in the middle, I think I can just add one more to the padding. Like if I add one more to the padding, I'm gonna get its padding plus one. Oh, that's gonna be one upon that. Okay, so we're gonna add 1.0 F to that. Just a bit more, you know, maybe two. Ugh, almost there. Maybe three. Which means it isn't even about that. So after I added one, yeah, those join perfectly, but there's a random line. You know what? I'm gonna try something. I'm gonna try linear, deal map linear. I'm gonna turn this to what was the other one? I'm gonna turn off anti-aliasing, but before that, I need to go do attack. I'm gonna be back. Okay, I don't know what's going on. It was supposed to be something I not anymore, I guess. Anyways, um, yeah. So what were we on about? Yeah, this random line going. So OpenGL tiles having a line in between. Often guys by text coordinates or pixel precision, the simplest solution is to add padding to your tile set, ensuring the edges of each tile don't touch. Alternatively, you can try using texture filtering, counting to edge, adjusting vertex coordinates to solve the problem. That makes zero sense. Oh, use GeoClamp to edge for the texture wrap mode to consider using GL nearest for texture filtering if performance is a concern. Oh. So let's try to use nearest. Near test. Let's try to use nearest and let's see if these lines go away. Please, please, God. Let's go. Okay, which means that was just anti-aliasing. But now they look really rough. Look at that. I don't know if you can see it on your computer. Probably can't. But it looks really rough because it's acting like pixel art. So instead, I'm gonna do GL, yeah, clamp to edge. GL clamp to edge, like that. Hmm, that's not right. That's not right. Am I still live? 6 hours and 45 minutes. That's pretty hard, bro. GL clamp to edge. If I'm doing a linear map linear, let's just see. So a GL nearest for texture filtering is a performance percent. Yeah. Pre-compute, alpha, blend, whatever. GL draws black lines between tiles. Yeah, sprite sheets and adjacent pixels leaking had to do with the way linear texture filtering works for any point in the texture that is not sampled exactly at the center of a textile mirroring sample for just computer the value. Since you cannot use something like geoclamped in a texture, at least you need to create border textiles around the edge of each texture. Yeah, because it's a sprite sheet. Unless the entire sprite sheet repeats, that's what geoclamped edge will do. But in a texture atlas, you need to create border textiles around the edge of each texture. These border textiles will prevent neighboring samples from completely different textures in the atlas from altering the image. Bro, what the hell? Yeah, so clamp to edge will do this. Repeat, then clamp to border, then mirrored repeat. Despite there being a mode called clamp to border, that is actually not what we're interested in. That mode lets you define a single color using border. However, we wanted to replicate the behavior clamp to edge where any texture coordinate outside the proper range. Okay, how we do that? We know that GL linear symbol sample the nearest 4 neighbors as seen as the diagram of, so we only need the one textile border. We need a border text border. Here's an example of a texture that illustrates the border more clearly. Papers, blah blah blah. We do some goofy. He bring nice dropping filtering, change the shape of the sample, neighborhood based on angle. And it causes more than 4 textures to be used in filtering. What is bro on about? Subtracted 1 from X and Y in the black coordinates. I did not proofread the image before posting. What? I did not proofread the image before posting. Bruh, that's crazy. We really have to do all that? Just a second. Assalamualaikum Baba. जी बाबा. I'm back once more. I don't think I had this many interruptions the entirety of the stream. But anyways, we're trying to remove pixels. Should I even? Should I even care, bro? Should I even care? It's trying to do something like this. So instead of linear map linear, GL to linear map nearest. What about that? Nearest map linear. Let's try that. No. Nearest map linear. Let's try that. Nope. Linear and map linear. And then GL clamp to edge for the magnifying filter. For the minifying filter, can we also clamp to edge? That isn't working. My God. You know what we could do? You know what we could do? We could do like a crazy thing. Overlay them on top of each other by just like subtracting like a really small portion of the screen. Oh, that's like okay. So we need to do that multiplied by J. Okay. That's cool. That's cool. That's cool. Look at that. We don't need to do all of that. We don't need to do any of that. Let's see if I can add another 0 and get away with it. No, I can't get away with that. So, look at that. Look at that beauty. Ooh. Mmm, yum. I'm honestly, that's pretty cool, bro. Let's make that a constant of like, what would you even call this? Like anti triple anti-aliasing, anti-aliasing border, anti-aliasing border. I'm gonna fast define that anti-aliasing border to be like a 0.01. Okay, now we're starting to ramp things up. We have a thing and we have a thing. Now let's create a player. But do we have that in our tiles? We don't. But thank God we have a class style, a sprite sheet. Um, a sprite sheet class, which will allow us to do some funny things if we ever need them. So let's just go out like this, and there you go. Nziv res base pack. Inside here we have player, and look at that. So we have a player one walk, and then we have player one sprite sheet.png, and player two sprite sheet, and player three sprite sheet. So let's go player one sprite sheet.png, and I'm gonna break my monitor. Have you seen that? But anyways, we have this cute player one doing player one things. Now you're probably noticing this weird border, and you're like, oh, whoa. Stop worrying. If we just use the alpha layer, you can see what I'm really talking about. Okay, this is our player, and it can walk. That's basically of course animation needs to be done, but for now I'm just gonna hold the 0 and we're gonna have to see the 1 2 3, right? And then 1 2 3 4 5 6 7. We have 7 by 3, and look how easy it is. Look how easy it is. Look how easy it is. 7 by 3, right? 7 by 3. I don't think you understand. 7 by 3. 7 by 3. Auto player 1 SS is equal to sprite sheet of not our tile type, but our player 1. Let's see if all the players have the same thing so we don't have to create like multiple of these. Okay, player 2 is the same. And is player 3 the same? Please be the same. Why would it be different? Yeah, let's go. Which means all I have to do is have a player and then just like that. Please don't do stuff like this. Okay. And the tile dimensions was I forgot. Just like that. I forgot. Who has time to remember all these things? 3, 6, 7. 7 by 3. 7 by 3. And then we have a tile padding. Ooh, that's a good one. How much is the... Is there any padding? That doesn't look like it. Not from the top, not from the bottom. Oh, from the top there seems to be like... Oh, but he jumps. So there's 0 padding. Look at that. There's 0 padding, and even to its right. To its right, there seems to be... There seems to be like 2 pixel padding, but I'm not really sure. So let's try that. Let's try 0, 0. And then instead of tile map, but we're dividing by tile map, there's going to be a division by 0 error. We're going to notice that. Then we have a tile map. And in this case, we'll have a player map. Player 1 map or player map? It's player map because there's a player. And so what we're oh my god, what's gonna happen? Turn into Shaggy there, or the other dog with Shaggy. Okay. So enum class tile type. So we're gonna have all of that, right? And then right here we're gonna have a player type, or yeah, a player type. And this is going to be okay. So it's not a player type; it's a player frame, right? Because there's frames of his animation. So right now, I'm just going to say is like. Unfortunately, you have to name. I think I can just get away with like a. Like, look, that's a duck. That's a jump duck or something. I'm just gonna say stand. For now, there's just one called stand, and we're gonna map that to. We're gonna map that. We're gonna map that to a player frame, and this is a player map, like that, player map. And in this player map, we're going to have a player frame. So in this case, player frame stand, and the vector 2, which is 0, 0. And isn't that cool? Because that was all we need to do. Remove this random backslash. That was all we need to do. And now we have a player 1 sprite sheet. You know what that means? That means I can finally introduce a player. So right after we create the tiles, maybe before, maybe after. After we create the tiles, we need I don't want to create a vector of players right now, but just the player. So player equals new player. So player. What does the player class even have? It's just an extension of character which just has an x and y and a velocity. I'm fine with that. This honestly should be just in the protected. Yeah, that should be in the protected. And yeah, we can have a player. Why no matching construction for initialization of player? Okay, x and y. So let's define an x and y. I think I'm gonna put it at tile width and tile width. And you know what this should do? This should just place the character there. So oh, I never rendered it. Okay. So we have a player, but we need to render it. So how do we render the players? For auto tile and tiles, and then we do all of that. But there's also something else. Once we've rendered that, for each tile, we also need to do that for each player. But okay, we can just do that once for each player. So for I'm just gonna do this once. I is less than 1, I plus plus, just so that I can create this into a loop later. And then we can have the scale elements. And look at this. I create a bind so that it binds the current texture of the sprite sheet. So I can say instead of tile ss player 1 ss dot bind, player 1 sprite sheet dot bind. And once we've done that, the model mat and the view mat and everything's the same. That's kind of goofy. We don't really. I'm gonna copy everything for now, and then let's see what we can change. So we don't have a tile anymore, and that's cool. We just have a player. Player.get position, player.get position, x and y. We can place that correctly. Then what happens is we can multiply that by our tile scale, and that's perfectly fine. Not really. We can have a player scale and then like make that the same right now. Player scale is also going to be 1.0f. Oh, sorry, 0.3f. And so where we were here. And then we're going to use our model mat, then our view mat, which is going to be the same. Then our GL uniform matrix. We're going to put that there. And then, okay. You see the problem? There's a tile SS count. But I think I can get away with just that. And then tile ss.get map. Instead of that, we can say player 1 ss.get map. And then tile can be player 1 ss.get type. Sorry. Player.get type. Not even get type. That doesn't even make sense. Get frame. So we can have the current frame. So m current frame. Current frame. Yeah, current frame. And then we can make this a player frame. And we're gonna initialize it to player frame standing. Like that. And so we're gonna have a getter and setter for that. So m current frame. Bro, gotta be goofy. Player frame. Get current frame. Return. M current frame. Set current frame. Actually, I don't want to set current frame right now. I'm gonna not do that right. Get current frame, and then we have a tile SS padding. So let's name that to player SS index, player SS index, or even not even index, like frame. And then player SS padding, player SS padding, player SS.get file dimensions, player 1 SS. We can get its file dimensions, and we're gonna get that by player 1 ss.get tile padding plus 1.0f. That should solve everything. We got something. It looks a bit fat. There seems to be some fatness. No? Is it just me? Doesn't it look like a... it looks like... This looks a bit fat, 1, 2, 3, 4, 5, 6, 7. Is it sad in this one? Everything's happy and then it's sad in this. Oh, I think it's just like a hitting animation. How much are we dividing this? 1, 2, 3, 4, 5, 6, 7 by 3. Maybe I'm just imagining it. Hell no. Hell no, bro. That should be double the length. It should take like a 2. I don't want it to take 2. You know what we're gonna do? This is why we have a separate model now. We are going to do some blingity blongity up my schlongity. You know, instead of creating a vector. Why have we just created a vector? Okay, instead of vector player scalar, we're also going to add to its y. Its y. So we're gonna do scale that by 1, blah, and then 1. That's supposed to be cool. This in the middle. This in the middle should be scaled by a factor of how much? How much? How much? How much? I think we just multiply equal that. Nah. Nah. Um, like 0.5f. Oh, sorry, I put that on the y. I don't know why I was saying y. Like 0.5f, like there. I think it's gonna change its collision. Woo! Not that big. 0.75. Yeah, look at that. Look at that, exactly 75%. That looks beautiful, bro. That looks absolutely beautiful. That looks absolutely beautiful. One thing I'm worrying about, I multiplied it by tile width. When I spawned it, here when we're creating the player, where is the player? Player one that says, where's the player? Where have we created the player, bro? Here. We put it at tile width, tile height. Oh no, I did not. There we go. Okay, so now this is supposed to start falling. Oh! Look at that. I divided by 2. I missed a height. And there you go. Everything looks better now. Na 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 na, better now, better now, na 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 na, better now, better now. So yeah, now we need gravity. Gravity. Isn't that fun? Gravity, bro, gravity. So each time we're about to render, yeah, we don't care. Update then render. So this is render, and here we're gonna update. Look at that, we're finally gonna use our input. So actually, let's just update that input. So every time we press W, or actually every time we press D, D, D. Oh, sorry. What am I doing? Every time this key D, please run, bro. Please show me the. Please autocomplete. Okay, whatever. Instead of printing yay, what we're instead going to do is player dot we have velocity, right? I can't really set X and set Y, but I kind of want to. So uh why don't we have a get an X and Y? Oh, because that's an entity. Where's our entity? Yeah, we have a vec2 position. So we can't do that. But we don't have a set. So let's publicly set it. Yeah, set position. That's gonna take in a void. And it's gonna take in a GLM vec2 val. And it's going to m position is equal to val. Like that. No? No likey? Ain't no way. No variable overload equals. Oh, there's a const. Okay. All these getters need to be const, bro. All of them. Okay, you know what I'm gonna do? I'm gonna do some cool Emacs magic. I'm gonna do something like that, and I'm gonna go back, and then I'm gonna hit const, and boom, everything's done. Isn't that cool? I think that's pretty cool. 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 Why did it run it? Oh my god. So now all I need to do is clear.set. Please, 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 come on, come on, come on. It's not protected, bro. That's public. These need to be protected. Protected. Entity. Character. And then we have a player. Please, please. Player dot. Can you? Not. Why is Orfu not? Okay. So set position, and we need to set this position to whatever its current position was. Player dot get position. Player dot get position plus. So I think we can just like translate. Okay, we have to like GLM translate our position to like please work effective expression. How does okay GLM translate takes the M and then takes a vector. So GLM vec2. Yeah. So we want to translate it on the X by some amount. Like on the X by 2 is really crazy. Like probably like that. Please. What? What's the issue? No matching function for call to translate. Are you serious? Oh, translate takes a matrix. Translate takes a matrix. So if I say GLM translate takes in a matrix, but if I say GLM add back to add, come on, bro. Come on, bro. Come on, bro. I know you can do it. Player dot get position +2. Can I do this, please? Please let me do it. 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 GLM vector add. Come on, come on, come on. No, you liar. Oh, okay. Between two vectors. Oh, that was fast. So we don't want that's still way too big. Oh, sorry. 901. Oh, look at that. We got our player moving. We got our player moving, bro. Can you hear the key? I don't think you can hear the key. Maybe if I keep talking so the noise reduction doesn't work. Look at that. What beauty, bro. So we're gonna get an else if, maybe even a switch condition. GLFT B के बजाय A. We have A. Then we can have like 0.01, like that. And maybe even like 5, you know? Maybe like 3, and not on the y. What am I doing? This should be negative, boom. Yeah. And now we can move left and right. Now we need gravity. Look at that. Isn't that cool? Okay, so we probably need to make this smoother with velocity and acceleration, whatever. But what we're gonna do, each update is player dot set velocity. Yeah, we're gonna increment our velocity by 9.81 meters per second squared. So we're gonna keep on 9.8 meters per second squared is the acceleration. That's gravity. So let's just make that a constant right over here. Let's define gravity. Like, let me just implement this gravity and then I have to go eat. I'll probably end the stream here. Maybe, maybe not. We'll see. Gravity 0.001, no. 9.81. That's enough. That's enough precision. We don't need more. We absolutely do not need more. Do not ever say that we need any more than this. Otherwise, I will start crying. So we're gonna set our velocity to get our velocity plus 9.81 plus our gravity, right? And our gravity is a GLM vector 2, which is on the x, it's supposed to be 0, but on the y, it's supposed to be negative gravity, right? And what that means is we're setting velocity, but it's like it starts crying because we've never implemented that. So we did that. Okay, we have set velocity now, and we can get velocity, and we can subtract gravity from it. I'm adding negative gravity, so subtracting gravity, and now that should be it. But just setting the velocity doesn't matter because we're never adding that to our velocity, right? So our player's velocity needs to be added. So our player dot set position, it needs to be multiplied by our player dot get velocity, right? It needs to be added. Like it needs to be. You see the problem with this method, like add position should probably be a better option, like, because this is getting way too cumbersome. So in when we're setting the velocity, when we're setting the position. So when we're setting the position, we want to like even when we're setting the position, we can even like make an add position. Add position PLM vec2, and that's going to say our m position plus equals to go, right? And same with our velocity. So we can say add velocity. That's going to return a GLM vec2 on its own, and we can plus equals that. And so the good thing about that now is we can add position, and we can say player dot get velocity. That's it. We can add velocity by just doing that. We can add position by just doing that. Isn't that cool? That should be it, right? This should implement gravity. Okay, I didn't return it. Oh, I don't need to return it. I'm gonna search for add again. Oh, add underscore. Yes, right here. We don't need this. We don't need to return anything. No return statements. Let's go, gravity. It was too quick. 9.81 meters per second is way too quick. Why did I think this is real life? Absolutely, why did I think it was real life? Not 9.81 meters per second. It's 0.001 f. It's arbitrary. Oh, it's gone up. It's gone up. It's flown through the roof. So I think we should make that negative. Look at that. It was incrementally. This gravity is a bit too strong. Maybe like 4. Yeah, like that. Maybe even 5. Yeah. Okay, so I'm gonna implement jump dynamics and everything soon, just right after I eat. That's gonna be like 10 minutes, 20 minutes. So I'm just gonna put a big break on. Okay, thank you. I'm gonna be back. अच्छा नहीं भाई ये सब कह दोगे बैन हो जाऊंगा मैं. Okay, so we're back. Except now I'm gonna play a game with my cousin. आ जाओ. वैसे ही कोई व्यूज नहीं है तो मैटर नहीं करता.
तो अभी अकेले हम
बेसिकली देख लेता हूँ. ये थोड़ा बग्ड आउट होता है मगर एक से ज्यादा. इज द लेब्रॉन. अच्छा तुम मगर अपना पावर अप नहीं. थोड़ा इसको छोटा कर दूंगा. अब अपना पावर अप मैं देख सकता हूँ और तुम्हें भी अपना पावर अप दिखाना पड़ेगा. तो मैं इसको
आपने एक बार मॉनिटर भी देख नहीं.
हाँ है ना मगर मैं आप ही को दे दिया. एक सेकंड मैं मेन में जाता हूँ. इसको मैं थोड़ा छोटा कर दूँगा. सही है ना. अब आ जाओ. यहाँ पे क्यों है. 3 में डालो. नहीं 4 में डालो. नहीं 5 में डालो. 5 में ही है.
पता कैसे चलता है कोई.
हाँ
पता कैसे चलता है कोई.
यहाँ पे थोड़ा बढ़ता है मगर ये भी रिलायबल नहीं है. बस चैट में कोई बात कर. ज़रूरी नहीं है मगर वो करेगा. बहुत कम लोग बात. एनीवेज इंग्लिश में फिर भी बात करें वरना ये अगर उर्दू में टैग हो गई और समथिंग तो. लेब्रॉन लेब्रॉन लेब्रॉन. हम स्ट्रीम कर रहे हैं गेम.
मेरे गेम प्ले की वजह से.
एग्जैक्टली. गो. अरे
Like that.
रशीद तुम्हारी हाइट 3 4 11 लग रही है. LeBron. So for context, this game is basically a free and open source software. Lag कितना हो रहा है. This is free and open source software, and that's basically it. It's one of the only games that's free, but it's actually about racing, and we try to play this battle mode, which allows us to like do this now, you know. My life is nigga. Bro's gone. Oh. LeBron. ठीक है.
1-0.
Yeah. Oh. Oh. Loki, yeah. Loki, huh?
Loki bro is so bad.
Where is bro? Ah! LeBron. नहीं. Ah! Bro think I can't see him. Disturbing the beast. Look into my eyes. Yeah. So if you hit just besides the pillar or under certain conditions, the cupcake does not act like a auto missile. Actually, it works.
How can bro be so bad?
It works. Can I get this? So less amount of times than it doesn't work. Bro, हमें somehow constant commentary करते रहना पड़ेगी.
Oh my god.
Make ad libs. नहीं.
Please make a store ad.
Where is bro?
You have to top, not give sound effects. And even the sound effects are so.
So I got a story.
Yeah.
My number one strategy to distract Rashid from playing this game because I'm about to lose. Okay, cancel. Oh yeah. Oh yeah. Okay. Okay. So this one time, sponsor times and all. This one time, gift to गया ऐसा हम कितने साल से खेल रहे हैं? How many years have you been playing this for? Like
years.
मौसम के साथ भी खेलते थे हम. We've been playing this for 3 years, and Rashid still hasn't beat me.
Like, I'm beating you. I've beaten you every time. 36-16. I think you forgot.
I think that must have happened in your dreams.
How the tables have turned.
How the turn up tables. You know.
Let's go.
Okay. Equal now. I सोचो ये बनाने में कितना time? How much time this must have taken? Because I've been trying to code up a platform and it's taken years. Taken ages. Enox even. Enox.
2-1, 2-1, 2-1.
That go. Bro. I'm about to boom. They didn't even try putting like any generic power ups like a bowling ball and a cupcake. Like what was this inspired from? There must have been like a inside joke and story. That's how all these low budget boss software. Bro, this is cheating. You can't keep getting away with this. Sorry for the interruption. Bro forgot he's streaming in a Pakistani household. देखो chewing gum नहीं like I mean I think they tried making a replica of Mario Kart but they tried their best to change it.
Hell no, bro.
This was their
no.
Have to help bro out. Watch him betray me 2 seconds later.
Bro ran away.
Acha, bro ran away.
How can someone be so bad? भी मार देता हूँ लेकिन so close.
यार
3-1.
Okay, bro.
You can win, bro. You can't win.
I can. If I believe in myself. Okay. I think I've got it now.
Why?
I've got it because I've seen your look at that.
I'm toying it, bro. I haven't लगाया. I did it.
Bro is not escaping.
How bro talks when you can't even hit a cupcake. Which is basically aimbot.
Time for my comeback. Time for my...
The comeback that never comes.
What? There you go. I'm gonna start singing Kickback. Copyright to नहीं
On the auditorial is not watching your stream, bro.
Twitch bots are. Bro, it's not Bro, it's not.
Bro can't even hit a cupcake.
This is not. Again, another one. Not the last interruption. But it's not the first either. Probably may start singing Karat because they could not afford AC money. 80 cone. Oh my god. Epic, epic.
Let's go, bro. First shot. That actually hit.
You know what else is gonna hit? Impeccable time.
4-2.
It's time to Tokyo Drift. Oh!
It's more like Lalu Kid Drift. If you know what.
Nobody knows what Lalu Gate is, at least. My God, I think 80% of the viewers were Pakistani last stream, so I bet most of them know.
Oh my god, you got the century, bro.
That's crazy.
I'm stuck.
Step
I'm
cousin. Go on.
That's cheating, bro.
I waited for you. Gotta get my money's worth.
4-2.
Because I definitely did not pay for this software. My kids are only going to have this game on their PC. And instead of making them iPad kids, I'm just going to give them a black box Linux terminal. And they're gonna have to figure out how to install Gen 2
no, bro.
from scratch if they want to watch YouTube.
And they can't watch YouTube, they have to watch Pipe.
They have to watch Invidious. Look at that. And once they figure out how to, by the time they actually figure out how to run the operating system, it's gonna be too late. They're either going to be prodigies. They're going to be in oh my god. Oh my god. Bro, but I've been speaking for 8 hours non-stop. I don't have the energy left in me. To stream gameplay. Oh my god, 8-ball pool. Swag like Ohio.
And bro is so tired, his brain got
Brain rot. Are you stuck again, Risheen? Are you stuck again? Bouncing in the background. I can see, bro. LeBron. You know, I've decided on making another. I have another project idea. It's that. What if we create an AI that was so intellectual? It had so much brain power. It was so big brain that it could decide objectively without bias, without emotion, or maybe just like a replica of what could have been the perfect emotion, right? In the ideal state of mind. It should okay. I can't focus on two things at once. How do people even stream and play games at the same time? So that AI is going to judge every religion, and then it's going to prove what the true religion is. Isn't that a good idea? Rashid,
No comment, no comment.
Rashid, I need your
Chad, what should we do?
Chat. Soeb, are you still watching? Soeb, we've gone from I'm caught lacking in 1080p. I'm not working on the project right now. But you aren't either, so oh my bro, damn bro, set me up for failure.
It's too good.
Bro needs to take a stretch. Take a second now.
Just 2 in.
I don't know. Now we look at that. Beautiful.
I don't know, bro.
That was the worst. Serious. That was the worst game I've ever seen.
I told bros give like it was mine.
Oh yeah. हो गया कि English equivalent क्या है?
It's done.
It's done. Like bro just killed someone. It's done. Yes, boss. The deed's done. Nahin, like
It's gonna be something.
it's like the Urdu equivalent of Shimatta. In Japanese, like
like no one is watching in Japanese.
Nobody's watching the stream full stop, bro. Maybe someone will watch the VOD and they're gonna read the title and they're gonna be like, came here for the programming, stayed for the gameplay. Imagine they start requesting you. It's gonna be sad. I'm gonna have to create an AI depiction of you. Who? Of you. In my face.
Why?
That's it. The good thing about this is now we can have like instant replay. Since this is like streaming. I can sing, bro. I just don't try. Like I'm not trying right now. I can win. Oh, look at that. Oh no. Please, please get away from me.
Big.
Am I too close to bro?
No way, bro.
Vertically upward.
Bro, stuff things up, bro.
Bro rigged the match. I still won. I still won. Instead of for another one. I didn't set the gain too high because I don't want the fan noise to interrupt our speech. Gotta use linguistics.
Professional streamer.
Bro is professionally unemployed.
Likewise.
But you could be called like a student. I'm barely even a student.
Let's go. Cancel, bro.
was bro waiting for?
Could I call step?
Step ladder. Oh. Gotta stop making these grunting noises.
Yeah, bro. That looks too sus from the outside.
Oh my god.
What is the score, like 10-0?
It's
10-5?
it's at least 10-9.
Oh, 10-9.
Oh, what do you say? I think it just went up by one.
Bro is not thinking. What do you say? It went up by 1. I don't care.
No! यार हड़ता मत भाई लगती है. Yours always hits. Like that's the gay shit. How many things in Urdu translated into English sound so much gayer? Ho gaya? I mean, ho gaya is kind of No, no, what? What?
Without this
No.
should be
Khudafa is like,
the
may
Pakistan.
God keep you safe,
Like I did not know that.
bro. The U.S. citizens and the burgers that are watching this.
Burgers. Burgers is crazy.
So, for anyone, for anyone who doesn't know, uh, for anyone who doesn't know, burgers are just people who have basically been culturally appropriated. You know, they've like completely left their own culture, and they try to act like they haven't left it, but they actually don't know their own language, their own cultures. You know, but it's mostly used in the context of Pakistan and Pakistanis, uh, maybe Indians, maybe, but you know, it can be used in both a positive and negative connotation because it has stop, stop, bro. It has evolved, you know. Even with all of these, you know,
Don't learn from
with all the slang that has been convoluted by Western terminologies. क्या कर लोगे? I'm gonna use the vocabulary. Let me, bro. Have you seen Ellie the Bot? Ellie the Bot is a VTuber. She studied from MIT. How did that not cancel? Bro, just ate my cupcake. And she's basically a what do you call it? An electrical engineer. The problem with bro trying to juke the juke. But the problem with that is that she uses. There's no problem actually. It's just a fact. So she uses a good English vocabulary. So I told this entire story just to say that. I think that's how streaming works, right? You don't have something to say. You have to create entertainment. I live for you guys.
We're just God.
No. Bro, just go to 1, 2, 3. Second, let me show you that. Is there anyone watching? Imagine if there's someone watching. Oh, been streaming for 8 hours, bro. 1, 2, 3. Chale. Oh hell no, bro.
हो रही है मोबाइल स्नैचिंग हो रही है मैं तो सोच रहा हूँ फिर से 3, 2, 1 पिल्ले
There's not the original. So it's 3. Why is I don't care about her wife. I don't care about his wife, bro.
ऐसी क्या चीज
Nahi. This guy's made spin off. 3, 2, 1 Pille original, bro. I need the original. 3, 2, 1 Pille. Where's the original? In real life.
मैं पिल्ले थोड़ी हर जगह पे मेरा नाम अवैस है तो कुछ जगह पे कुछ इज्जत भी मिलनी चाहिए ना हर जगह पे ही मजाक मस्ती हर जगह पे ही मजाक मस्ती अभी बंदा किस टेंशन में कभी घर की टेंशन है कभी किस चीज़ की टेंशन है तो बंदा किस टेंशन में बाहर जाता है तो बाहर से आगे से मजाक मस्तियाँ हो रही हो तो कैसा दिल में फील होगा आप खुद बताओ बुरा लगेगा
Anyways, I probably have to blur that now. For reasons unbeknownst
For
to
Mamba
man.
reasons.
For more reasons. Oh. I gotta censor that shit. Look at that. No? They call me, you need a, bro. Oh, feisty. I didn't touch it, bro. Karma got to, bro. No. Oh! Oh, yeah. Cornered?
Oh my.
I cornered bro in like a.
Come here.
No. No, not 2. 3. I got 3. Okay, bro. This is unfair at this point. Unfair. 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 But I still won. That's just the nature of the game. Every time the turn have tables, bro.
Turn your table.
No, no,
I'm gonna take my
No.
shot like
no. Steph Curry. They call me Steph Curry. How much curry I'm eating, bro?
that was
Joke
not
ever.
hell no.
They call him LeBron. How many James he eating?
Yeah.
You get Steph. How much curry I'm eating, right? So,
What are a gem, bro? James?
James. इसका भी कोई था ना. इसका भी कोई
कुछ
mean.
नहीं था आपने कुछ
Bro, there was like a James. James Charles? No. Imagine if
Hi sister.
imagine if James Charles is
And she says that she will not give us 100,000.
Did you just say she? Ain't nowhere about his gendered language.
Oh hell no, sorry, I'm sorry.
Bro,
They-
I gotta apologize to God.
They, them, I pronounce.
Bro, swerve on that corner. Oh.
Nah.
Bro, swerve on that corner. Oh. Gotta shake in the bacon now, my God, bacon now,
Bro does
bacon.
not know the song. Bro just has to sing.
I know the lyrics.
You don't know the lyrics.
Look at that, boy. But bro did not sing. Oh my God. Okay. I mean, Dunno. Dunno. Dunno.
Done. Are you done?
Is bro? Huh? Are you
done?
Are you done with your mischievous activity?
Are you done?
Are you done dilly dallying? Is bro done floundering and floundering?
Why is LeBron coming?
Bro, bold. Right into my alley.
Hell no.
Ugh. Bro, you're gone. You're gone.
Broken.
Was bro taking advantage of me? Bro, stop. Stop taking advantage of me. I'm not a little girl. Like, I mean, I did not mean what I meant.
I
Look,
like,
I'm basically
cannot
not even
talk, but
legally
yeah,
an adult, you know?
like, I'm not,
Done 8-ball bro people. 8-ball food people. 8-ball pool.
oh yeah. Bro, just acting.
Bro, 8-ball pool bro. मुश्किल है क्या देखो. Bro. I think most of our laughs have been cut off because of the noise
When bro
reduction.
is only good at one thing.
What does that mean? What is that supposed to mean? Hit swerve at that corner.
Ada ka na.
Oh my God.
How can someone be so bad? Like,
Yet
dying
so
in
great
29
at the same
seconds.
time.
No.
You
Hell no.
Tables turning half. I just hit bro. What? I just
hit on bro. That's not sus.
That's us, bro. That basically means that
That you
I canonically have been-
canonically.
that's a real word. That's definitely a real word. It means like what does it mean, bro? It means I have 3 swatters. Do you think the one cupcake is gonna stop me?
You see how I just left the shift. I'm gonna kill you with a sword, bro. Sorry.
Okay.
Want you
It's
here
fine, bro.
with me.
Bro forgot I cannot be rage bait. You know what they say?
When was the last time you won?
When was the last time you showered?
Like 5 minutes ago.
5 minutes. That's crazy. You showered on stream? That's kind of sus, not gonna lie.
I bet you love that shit.
What? Bro, stop. Why do you have...
Are?
Nah. Nah. Nah.
Bro got
Let's go. Bro
Bro,
got
bro.
threatened. No, I did not like this. I do not like this. I do not like this at all. I do not like this. I do not like this. I do
Oh
not
my
like this.
God,
I do not like this.
that's
I do not like this. I do not like this. I do not. I don't like this. I do not like this. Yes. I do not like this. Oh my god.
Bro, it's just too bad, bro. Bro, it's just so
There should have
bad.
been like a score counter. I think I
Yeah,
should.
bro.
I should, git commit that to the
Program this shit.
program this. Yeah. I gotta make the cupcake better too.
You gotta.
I gotta. Can't be
Yes.
using too many syllables.
We'll just talk to
Talk to
Allah. You gotta
gotta. Oh, did I cancel my cancel?
can the cancel.
Oh my god, bro. Oh, imagine if that hit. Imagine if that hit. Want you to understand that nobody's.
Bro, I'm sorry.
As soon as I. Bro, this is why I don't trust you.
Bro gets rage baited so easy.
I probably need to change the stream title.
I don't think you have a project due tomorrow.
Oh yeah. So basically, this Bloodbound was a university project. Not was. I mean, technically was now. It's dead now. So it was a university project.
You were a university project.
What?
What?
I wanted to make a university project. So I thought might as well stream it, because I have zero motivation, and just because it's something related to university, it automatically makes me want to stop studying and stop building it, even if it's interesting. This project really is. Look at how fluent I am when I'm yapping. But when I'm
Bro,
trying
the master
to,
yapper.
bro, and you love to rage bait, so we can call you a master.
Later.
So-
Bro, delete that shit. No one clip that. Chat, don't clip it.
Dad, don't go. Dad, don't go.
Whoever clip that is gay.
The 10,000 people.
But that's totally okay.
Oh, bars, bro.
I would love you anyway.
Oh. Have you thought of becoming a professional rapper? What if you rapped on stream for us right now? Right here now. Imagine if Ninja got a blue paper. Bro thinks I'm not seeing. But bro really forgot. What's bro doing?
Okay, it's okay. I just lost for the first time.
Oh yeah, definitely.
Yeah, definitely.
You definitely didn't lose your entire ego.
I don't have an ego.
So you can't lose it? That's a pretty good response actually. I'm gonna use that next time.
I'm trying to work as well, bro.
Ain't no way.
Bro, such a dumb.
How dare you say that to me? I'm gonna break my monitor.
Oh, I'm gonna break my monitor.
I'm gonna break my monitor.
I think you should.
I swear to God.
I think you should show that clip.
I think I should.
I think you should
like exponentially. How many years of Look at that auto sensor. Look at this.
Stop him! Great goalkeeping.
Okay, first my impression and then yours.
I'm gonna break my monitor, I swear.
I'm gonna break my monitor. I
No
swore.
way. I swore. Bro swore in the past.
By Handanovic.
Check.
Man, I'm gonna break my monitor. I swear. Oh!
Bro said he said swear.
I swear.
I swear. It's his Canadian
Swerve,
accent.
like
bro.
swerve.
Like swerve
I was
at that
closer, I was
corner.
closer.
Oh. Okay. So back to programming. Gotten this far, we've implemented gravity. Now all that's left is trying to yeah. Okay, since we have gravity now, let's just let's see what we can do. What can we do, bro? So yeah. So we have like done this. I think I'm gonna open the AC now. A sec. I'm gonna close the fans in a bit, but right now, then you're gonna have the crisp audio. You're gonna have so how do I even implement collision right now? We're gonna have to check if I think just normal collision detection by less than signs will work because everything's from 0 to 1. So if we're updating it, we're updating here, and when we're using this, should we on every point in time? Yeah, I think in every point in time, not just for gravity, but in every point of time. If our so we add the position, we add the position, and then we add the velocity, and then we add the position. So every time we've added the position, we're gonna check if like we're gonna change it by that value. So like it's gonna be our value is gonna be negative 0.23, and then at the end we're gonna add it. Or should we do that on every check? Like, okay, you know what we're gonna do? We're gonna say player dot get position dot x dot get position is less than player dot dot. Okay, so we're gonna have to loop through every entity and check if there's a collision. We're gonna have to check through every entity and check if there's a collision. So for auto entity, there's gonna be an entity in. For now, we only have tiles, so I think that's cool. And we can just check if the player.get position is less than any of these tiles, so any of these entities dot get position. Right. So it's less than. I think the less than sign doesn't work. So it's not really about less than, is it? Player.get position and entity.get position. This is gonna take the center. Now its collision box is going to be different, multiplied by the player scale. But I think if we use the oops, why is it loading? Why is it saying connecting with that? Why is my internet going away? Why is the internet freaking out? It says welcome to the chat room now. Why does it say that? Well, is the compressor working so I can talk this quiet? I can talk like here. Can I talk here? Can I talk loudly? Okay, that's hitting the red zone, so I'm gonna avoid doing that. But please, internet, start working. Please don't end the stream. 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 Have I actually ended the stream? It says offline. I'm not offline, bro. Can I still not ping new.org? Okay, I got responses. So stream went off offline back to Twitch. How to turn OBS says I'm still streaming, but Twitch stream, yeah. Wireless connections and calls because of the unstable nature. Please, is it working now? Okay, it's showing that. Oh, I'm live again. Okay, let's go. Wait, why is it showing 11 seconds? No, please, no. Oh, thanks. This fault. Bro, what? I have 5 followers now. That's crazy. Who followed me? Bro, making a game that will ruin friendships, creating a game that will ruin. What? Continuing the creation of Bloodbound. That's annoying. Why did my stream split into two? My stream split into two, bro. My stream split into two. Okay. At least I'm online. At least I'm online. At least I'm online. And is everything even visible? Everything is visible. The program main is visible. Okay, let's just I'm not muted. I'm not muted. Everything's fine. Let's just watch now. I'm gonna watch my own stream because I'm cool. Sorry, I just need that extra view. So player.get position. Now we're gonna check if player.get position.x is less than entity.get position.x, and then same thing on y, 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 same thing on y. So if both of those conditions are true, then we're not gonna do anything. But if any of those conditions are true, so or right, the player dot get position, that's going to be the center of that. We're gonna add to that player scale, but that's only on the width, right? So is that like I'm gonna rename this player scale to player scale width. Player scale width. Come on, you can do this. Okay, let me try to rerun eglot. Okay, apparently not. So I'm just going to I'm gonna find player scale and then replace it with player scale width. Yes. That's it. Now player scale. Okay. Scale width. So we're gonna add to that. But it's weird, right? It's multiplying our position by that. It's multiplying our scale by that. I don't really want to do that. Like divide by 2. But it's like if I took file size divided by 2. That's what oh my god. Yeah, if our let's see. So we have our player. Why did I draw the kanji for tree? If I have a player, right? And this is 1. So it's shrunk down 75%, right? And now what we're trying to see is if it's colliding with a block, of file size, right? So what we want here is player.get position, which is this, plus that on the right side. So first we check it on the right side. So if player.get position.x plus player scale width, we're gonna have to check that once more. Divide by 2 is less than or is greater than entity dot get position entity dot get position dot x. We're gonna get its x. We're gonna get the x position here, and then we're gonna subtract half of tile size from it. So subtract tile size, tile width. So how are we calculating tile width? So here we're calculating tile width by doing all of this. We're saying 2 divided by aspect ratio minus whatever, right? And what I'm gonna do here is I'm gonna say I'm gonna say player width. Player width is just going to be tile width, but multiplied by 75%. So multiplied by not player scale width, but really player scale width. Player scale width. So if I say player scale width, no, this. Oh my god. So I'm going to have to replace player scale width with player scale again. I'm gonna do that everywhere, and then player width is its own thing. Player scale width is 75%, and we're just gonna multiply that by that. That's what we meant, scale width. So like maybe we're gonna search for 0.75, and here that's going to be player scale width, like that. And so come on here. So we're gonna get player scale width. No, player width. We're just gonna get player width divided by 2. We're gonna add that to our entity, our player position, and we're gonna check if that is greater than subtracting that. So we're checking if this side. So we're done checking this side. But what if that really happens? If that happens, we're kind of screwed, aren't we? No, we're not. Don't worry. We're not screwed. All we gotta do is set our player position. We're gonna set that position. Set that position to player.get position. But we're gonna take its x. We're gonna glm vec2. We are going to take its get position x, and then we're going to we're going to take its position y, because that's supposed to stay the same. And for the width, for the x position, we're going to set it equivalent to that. Right? So what this allows us to do, what this really allows us to do, that doesn't make any sense, but okay. Yeah. So we're basically saying if we have crossed this line, set the player position back to the edge of this. But it's gonna be opposite. So set the position back to entity.get position.x minus tile width divided by 2 minus player width divided by 2. Right? And same with bottom. So if our player.get position dot x on the, so let's just try y, because I want to check it quickly first. So player.y has let's check the bottom. So the bottom face is this, and what we're saying is this plus the player height, which is basically the tile height, and I'm going to set that equal to that. So hash define player height is equal to tile height, just like that. And what? Gravity? Yeah. So player.get position.y plus player height divided by 2 is greater than, so now when we're talking about greater, what are we talking about? The 0 0 is here, right? 0 0 is here on your screen. which means so if 0 0 is here on your screen, what that means is this is greater. So yeah, if it's greater than entity dot get position dot y, so we get its y position. Bro, close this. Nobody needs. I don't see. And then right. I don't need that either. Yeah. So we have this plus player with divided by 2 is greater than Kyle entity whatever this is entity dot get position dot y minus Kyle with divided by 2. We're going to set player dot set position equal to glm vec2 entity, and what we're basically going to do is we're going to set it back to the second part. Set the second part, except we're also going to have to minus player height divided by 2, and for that's going to be the y. So that's going to be the y, and for the x, we're going to have an entity dot. It's going to stay the same. So we're going to get player dot get position. I'm going to get its x. And now, if even that does not work, we're going to get position. We're going to get position dot x minus our player. For now, this is enough. For now, this is actually enough. That's kind of wrong though. Maybe it's exactly behind one of these. I am not gonna draw these. I'm not gonna draw the tiles. Just to see. Nowhere to be found. So it shouldn't be inside a tile. The distance between this, let's say, the distance between these two must not exceed a limit. That's exactly what we did, right? Because this says if any entity where is it? Hey, how's it going, Lena? I've been streaming for actually 8 hours now, and the stream just cut off my internet. My Ethernet cable got a bit loose, so I also want to learn this. Really, that's great. What do you want to learn about this? What I'm doing right now is let me just show you. Let me just show you. Let me close this and show you what I've made so far. Look at that. We've got gravity, we've got tiles, we've got sprite sheet. So I'm coding this up in OpenGL and C++. How much do you know about programming? I can guide you through the rest, so I can explain a bit. But I've been doing this for 2 streams right now, so yes, just a second. Just a second. I'm programming a 2D platformer where yeah, so I'm programming a 2D platformer where there's going to be two princes, and they're going to have to cooperate. And I only know simple website development. That's cool. So basically, the rundown is there's a lot of code here, but the two great resources is that learnopengl.com, and this will explain all the math and everything behind it. But what we're doing right now, and I'm going to give you another resource, that's learncvp.com. These two are basically cvp. Learncvp.com is going to get you cracked at C++, and that will allow you to enter the field of graphics programming and everything else. Then we have learn OpenGL, and OpenGL will allow you to create more games and make them 3D and everything in between. The thing is, with these sort of making this from scratch, because you can use SDL or other things too, but they all use OpenGL or Vulkan. But this is this will take a lot more time and effort. But as you can see, that you have control over everything. So right now, what I've done is I've taken this free and open source res spreadsheet of tiles, and so what I've done is I've mapped coordinates of our textures. Yes, I've mapped texture coordinates to by our indices. So I've specified the types of block, if they're lucky block, if they're dirt block, and then we can just here let me show you. So I've created a tile type, which is grass meadow. It's very yeah, but I think if you follow along, I've also uploaded on to my YouTube channel the previous WOD. I explain every line, but I give an overview of it. But this is basically like for people who have like a general understanding, but have never really tried it. I personally haven't ever built a game, even though I've been programming for quite some time. But I thought this was a good excuse to start programming and start actually developing something. So here I've created some tile types: grass middle, grass left, grass right, and then dirt middle. And then I've mapped them to like indices on the sprite sheet. Like if it's gonna be flipped for you. So 1, 2, so 0, 1, 2, 3, which row and which column. We get that index, and then I do some really fancy maths here. It's not that fancy. Yeah, thank you. But here I multiply the tile size by our SS index, so our index, and then we add to that our tile size, and then we subtract some padding, 2-pixel padding between the sprite sheets. As you can see, there's usually a bit of padding in sprite sheets to not blend them completely, so that 2-pixel paddings. And then we can just what else do we do? I don't know much aside from that, but here basically we create a buffer, right? A buffer is just a space in memory, and all we do to it is we upload some data to it. In this case, we upload vertices, which is different points of our shape. And so we usually work in triangles because a point is too small. A line is still not enough to make like fill in a shape. So the smallest shape we can get is a triangle. So once we have a triangle, we can use two triangles to create a quad or quadrilateral. And so once we upload this, so basically I'm making a game. Yes, I'm making a game. I'm making a platformer game. And this is actually a university project. I didn't have to go this overboard with it, but I decided to do it, and I have to publish this tomorrow morning. I haven't really gone, like, I've done 90% of the work now in these past two streams, but I need to do some more, like implement collisions, and that's what I'm doing. What I'm trying to do right now is trying to detect if a player is close for touching a block, and if it's touching a block, are you Yeah, I do some work on the side, but I mostly do a job. So in the same field, programming. I've made some projects too there, but yeah, I'm open to it. I haven't really scouted for it because I've uh, quite a few things on my plate, but still, I'm open to it. Oh yeah, yes, I'm a student. I'm a second semester student. Um, I'm in my second semester in FAS University. So I'm in computer science. I'm completing my computer science degree, and yeah, that's it. So it is it is taxing to do multiple things at once, like trying to find the balance between how much you need to work and everything else. But I think I can get it done. And I'm getting a 3 month break right now, so I might be streaming a bit more. Uh, yeah. So with the website development, what was funny to me was that I actually learned OpenGL and all of this stuff first. I learned all of this and then went to web development, and then I learned React and everything. I was putting that off because, as you can see, I'm using Linux right now and window managers and everything. So I really cared about how much, you know, I was. How do I say this? I had the old school of thought basically that you shouldn't have too much bloatware, which means you shouldn't have programs that take up too much space on your computer or take up too much of your memory. Like it's a popular joke and meme now that Chrome and all of these programs right now take up a lot of RAM and eat up a lot of your CPU. But you don't really need that, right? You can use like even Qt browsers in general are just pretty bloated, but still. So I started making things from scratch. So even when I wanted to make a game, I was like, I gotta make it from scratch, and I gotta make that too. I gotta make that too. So I kept going down the rabbit hole, and so I basically am here. And I had quite lot of projects for myself to make. I was thinking of recreating PyTorch, like the AI library, from scratch, so we can have machine learning and everything from scratch. So that will help me and people who watch the stream learn a lot more about how the internals of sorry putting microphone, but it will help a lot for them to learn the internals of how everything else works. Let me turn off the fan for a second. But yeah, so that will help all these things a lot more. So yeah, I decided to do this. But if you have any ideas or you want to learn something new, or yeah, anything, any project, because I have loads of them, but I can't decide what to do next. So if you have any queries or anything, even you can stop me and start asking what each individual line of code does, and I can explain that. So it's like it's also streaming has also brought myself motivation to sit down and just finish these projects. But yeah, it's really helpful. Uh, what else is in general here where I live, there there's a there are a lot of people who are trying to work on just the surface level stuff. They don't want to go down the rabbit holes. They don't want to increase their knowledge in depth, and that costs them in the long run. And I think that really does cost anybody in the long run. Once you try to start to get a job, you're going to start cutting corners. How many you used in this game language? I'm using just C++. That's it. OpenGL is an API specification. That's a big word, but what it means is API is application programming interface. You probably heard of that in web development. But the specification is that it's not even an API. It's like a blueprint on how to work with an API. It's like for AMD chip, how are you going to have access to the GPU? How are you going to have access to the screen and monitor? So in rough terms, of course. So for AMD, OpenGL, the company behind OpenGL, and that's Open Graphics Library. The sorry for that. The people behind OpenGL, there's a company called Kronos, and they're the ones who created the newer Vulkan, but though they just laid out a specification of different things that AMD, Intel, and every other GPU manufacturing company has to implement before they can completely rely on any game of them is working. Your stream is lacking. Um, lacking or lacking? Yeah. What is lacking? It's lacking quite a lot of things, but can you tell me what specifically? Or is it lagging? Like, let me just see. Um, it's fine for me, but by lacking you mean that I haven't configured my about me and for hanging. That might be an internet connection issue on your side. I'm watching this on another device as well. I was watching this and this is fine right now. Try to refresh the page maybe. I'm gonna try and see. Can you cut down the quality? Maybe you have an option to set it to 720p. Because I would have to restart the stream for that. But maybe. It's okay. Okay, thank you. So but basically yeah. So AMD and Intel have to listen to that specification and build an API around that. And that's how everything, like every other game, is made. Um, Earlier in the stream, I was playing a free and open source game. By free and open source software, I mean free as in freedom. So tell me, is there this that you were doing? Yeah, this is basically I was tasked at my workplace to create an application that would listen to brown noise, that would generate brown noise in real time. So that took some math, but then also display it visually. So you need to take in that noise data and then maybe even thunder or whatever rain, and you need to procedurally generate it like in real time. And while you're doing this, you also need to create a visualization out of it. So like there's a boat right now I'm creating in Blender, and then there's a river going in the middle, and you're having the POV. You're seeing through the boat, you're seeing through the man riding the boat, and the boat's gonna shake based on how heavy the audio gets and how it's an entire website. And I tried implementing that on mobile first, and that works too. But I shifted to making it on a website, and through on the web you use WebGL, which is basically the web version of OpenGL. So it's basically the exact same thing. You use the same functions, just a bit different and a bit crappier because of JavaScript. But if you use TypeScript, it will alleviate most of the issues. Though things like STBI, which is basically a library that helps you load textures, and the other is like any 3D model loading application. So you create something in a 3D modeling software, 3D modeling application like Blender or Maya, and suppose you create this boat, like you create this 3D boat, and it's all cool, but now you want to get the individual points and picture points and coordinates and all of the data that makes up this boat, and put that inside your game. How are you going to do that? So you can either write that from scratch by reading up the format in which it's stored. And there's just one format called the OBJ, which is very simple. But other than that, all of the other formats are really complicated to build yourself. So what ended up happening was I spent a lot of time trying to implement those, parsers, and trying to parse all of the data from scratch, but it didn't really work. It was very bad. It didn't work with some models. It worked with only others. It was very slow. So what ended up happening was a 3JS, right? 3JS. You've probably heard of it in web development. It's basically an abstraction over WebGL, and they basically create it's a game engine. So you can, with only a few lines of code, you can get up and running with WebGL without having to learn all the maths and everything behind that. However, once you're writing the shaders and everything, you're basically going to have to learn that eventually. So yeah, so with any visualization, so this is one of the practical applications for any sort of visualization software, even any GUI software. So if you have any immediate mode GUI, we want to add buttons to it and everything. Nowadays, GUI is pretty dead. You basically have websites now, mostly for UI. But yeah, aside from GUI toolkits like GNU Toolkit and others, you can just have you can create your own from OpenGL. You can say, okay, are we hovering over this button, and then add that, and then write text on it. But to write text, you're gonna have to load up a font, and then to load up a font, you're gonna have to do a lot of things. So I might even make a GUI from scratch here. You know, one of those is I'm GUI, which stands for immediate mode GUI, but it's also like a pun. So I'm GUI. Bloat-free graphical user interface for C++ with minimal dependencies, and that helps. Look at this. You can have visualizations, real time. The thing is, this updates 60 times a second, like a game. This updates 60 times a second. It's not waiting on most GUI applications and frameworks. Wait for you to tap something or for something to change, and then it sends like a signal. That's what it's called. Like even in Qt and everything, it sends a signal, and then that signal gets received, and then through that there's a callback, and through that some action takes place. Some action takes place. But with IM GUI or immediate mode GUI, you just have everything on 60 FPS. So 60 times a second, you're checking. Oh, has anything changed? Oh, has anything changed? Oh, has anything changed? And if nothing has changed, you don't do anything. As soon as something has changed, you change it. The good thing about this, the advantage with this, PHP. That's actually one of the only languages that I did not learn. It was kind of purposeful. I even learned some esoteric languages like Common Lisp and Haskell, but PHP was like I know about it. I haven't like learned it fully. You know, that and maybe Ruby, just a bit of Ruby, but other languages, no. And that's because PHP isn't that used now. I know it's like PHP usage is still high. That's like how many banks still use COBOL. A lot of them do, but newer applications don't adopt PHP, right? PHP usage. We're gonna get it. Yeah, WordPress and Laravel. Aside from that, not much. Look at that. PHP is used by 74.2% of all the websites. Yes, HTML, CSS, Java. I know. JavaScript. But for Java, I did give a certification, but that didn't really help much in the practical sense. But that's it. So I did learn Java for that. I spent quite a lot of time on Java, but I'm trying to get used to you know digging down into one language. The one I spent a lot of time with was this Common Lisp. It's not used at all like nowadays, but a customer Shopify. That's great. Have you tried building any application from that, or are you also a student, uh, or are you just learning as a side hobby? What are your interests? Uh, but yeah, so I'm interested in that. Not many people, chat. They usually just view and walk away. So I'm happy with that too. So yeah. Aside from that, I think streaming here isn't that popular where I live. I've worked for many clients, but now that's really cool. So even in WordPress, custom or Shopify Wix. So on those projects, did you have fun? Like, have you just picked up programming as a hobby? Because I picked up programming. I didn't find that clients of this. Yeah, you don't really get specific clients of this. This is not freelance work. It's more of a project based work. People like project managers and everything. It's more in depth. They have to spend a lot more money on this. So it's usually job based. You usually don't find people like kernel writing. Let's suppose you're writing an operating system. Let's suppose you're writing a driver. There's definitely places for that. There's a lack for that. You need people that. So I want to learn something new and market demand skill. Yeah, exactly. These skills are really important. So you can join the stream. You can join the streams. I'm gonna be trying. I'm gonna. My main goal is to complete a project in a single stream. What do you advise me? So it depends on what your interests are. You could go in multiple directions. Like I said, you could go into uh, like you could go deep into the C++ and then OpenGL and then writing drivers, then kernels, then operating systems, and you could go like into the bare metal stuff. That is really cool, and if you enjoy that, that's also really cool. That's the path I went down. The problem with that though is there's not a lot of demand. Even if there is, like there's few people working on it, and it's really highly paid, you know. But with once you have things like web development, there's a lot of demand for it, but it's also not that highly paid. Meanwhile, if you go into mobile development, you can use OpenGL in that too if you have to make a game or something. But in other cases, if you just have to make a mobile application, it's not going to take that long. What I suggest you do, you could also go down the AI path. You're going to have to learn a lot of math for that. What is it? What is what? Um, Mobile development? Mobile development is the applications you create for your mobile, like here. That's it. But if we're talking about web applications, the even in web applications, you could go into like stock and creating on quantitative analysis, and quantitative analysis is an entire field on its own. You could write these somewhere. So quantitative, or you could rewatch the stream or when I upload it as a VOD. But quantitative analysis is when you're using maths to build a model on how to exchange stuff and how to create a profit from it, create a profit from your product, and at the same time, um, try to. Sorry, it's been quite a bit of time since I've been streaming, so I'm getting tired. I'm not that used to this. It's not. It hasn't been that long. But what was I saying? Yeah, you could go down the quant path if you're good at maths. You could go down the AI path if you're good at math. Generally, in programming, if you want to really go to higher places, I'm not that good at math, but I really do enjoy it, and I think the enjoyment is what matters. You don't really need to be good at math. You just need to enjoy it. For this, you just need to enjoy it. That's it. That's all you need. Um, but yeah, great. So, um, for AI, just recently got into that whole thing. So with that, uh, you can go down many paths and you can incorporate that into anything. And I think like knowledge in general is just like a web of things, right? So you have you have like programming here, and on the opposite side, or some logic like math, right? You have maths here, which is completely logical, and then you have on the other side some creative arts, and that's like completely creative, like abstract art even. And then how when you learn each field, like you learn communication, you learn different things, all of these things converge into one. They converge into one place, and they allow you to look at the problem you're trying to tackle in different ways. Once I was basically obsessed with logic, so I completely ignored the creative side of things, and I never really focused on it. But once I really did, I noticed that I could see my programming get a lot better. And why I got into the creative side was not that interesting. I just wanted to make a game for myself, so I need to learn 3D modeling for that and some basic pixel art. Um, but yeah, so if everything you learn is interrelated, it will help you learn other things better, and then you can even grow the meta skill of learning. So you can learn how to learn things faster, if that makes any sense. So all these things help, but it so if you can look down all these paths, and what I thank you for giving me positive reinforcement in the chat. But if you have any, what I suggest you do is exactly what I did for myself, you know, um, and that's that you try every field, That's the point. Yeah, that you try every field. You try, like, let's say you're in programming, right? You learn about crypto. You and how you learn something is not just you use a library. You learn how to use the library, and that's it. You're gonna learn how to make it from scratch. You're gonna say, okay, I'm gonna learn C++ first, or C. You know what? Just learn C. That's simple. Just learn C. And that's not gonna take long. You're gonna learn pointers and everything, but um, you're not gonna take too long on this either. But you're not going to like go with it at a surface level. Thanks for giving me your time. Like, no problem. But yeah, so once you spend um some time in each of these fields, you rewrite them from scratch. You rewrite cryptocurrency. You write a blockchain from scratch. You write a game from scratch using this OpenGL. You rewrite an AI library from scratch. Once you do all of these things, you're gonna get to a point where you're gonna know basically a lot. You're gonna know a lot, and in each of these fields, you can incorporate stuff from the others. Like I incorporate web development plus the audio programming that I did, plus the OpenGL that I learned here, um, plus even the Blender 3D modeling that I did, all on that same project. But if I didn't know any one of these, I wouldn't have been able to make that project come true. Even make a prototype. So and I'm also going to incorporate AI to check the mood and everything. So all of that's gonna really help. You know, just 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 keep on learning. Once you keep on learning, you're gonna find that it gets more interesting to learn. It gets easier to learn, as I was saying. But just a second. Okay. I'm back. Sorry for that. Okay, we'll talk tomorrow. Sure. Thank you for joining the stream. Why aren't there timestamps? Timestamp. Timestamp. Okay. And so we are going to try and implement collision now. We're gonna try and implement. What's wrong? We're gonna try and implement collision now. And so collision includes. Where is my collision? Collision here. So inside our collision, what we're trying to say is if each of our entity, and we have one player, so our player's x coordinate is plus our player with divided by 2. So if our player's right side, if our player's right side is greater than any entity's left side, that's what we're saying. Any entity's left side. That should happen. But if our player's height is players, so this player entity of position plus our height is greater than any entity's y minus tau. So any entity's top side. Then we just want to set that to the same position x that it had and just that y. What I'm saying right now is what if we just did this? Look at that. And then look at me fall. Oh. What's happened here? That's interesting. So we get that velocity. So maybe we can add our velocity to be that. And then 0.0f. And same thing with here, where we can just add the velocity. So that should be the same thing. Just like that. However, but it should add 0.3 and then have a max velocity. So there needs to be a max velocity. We don't add or reduce the velocity below. Actually, that can be add position. That can be add position. That will produce too many problems. I don't know why it's not falling off the cliff here though. Why is it not falling off here? It's like we keep adding the velocity and we add the position. Oh, because the x's need to match. So we're saying and player dot get position dot x must be within. Must be. So this point, so our left wall must at least be less than their right wall. So our left wall, so and on player dot get position dot x minus player width divided by 2 must be less than entity dot get position dot x minus tile plus tile width divided by 2. So we can just simply set this position, or we can simply set the position to the same x, but we can cut out the height. So I think it should work now. Look at this. Look at that. It kept adding to the gravity, but so this, it kept adding to the negative gravity. But here, whenever we're set here, we're going to say player dot set velocity CLM vector to player dot get velocity dot x, but then 0.0f on the height. And so now if we fall, look at that. That's beautiful. I'm not calculating the player height correctly. That's probably true. Let's just see what the player height is. The player height here is just tile height. Is that not true? Is that not true? Is that not true? Tile width is 2 upon aspect ratio and all of this. Yeah, I can't think of something that would cause me to change, Player get position of y plus player height divided by 2 is greater than entity dot get position y minus tile width divided by 2, and then player get position. But we also have to have and player dot get position, like all of this is the same, but its right wall must be its right wall must be greater than its left wall. Its right wall must be greater than its left wall. And once all of those conditions are true, we can put the position to 0. Do this. Right? But if we are here, let's just add to our level. Let's just add to our level. Here, level 1. We're gonna have a tile type none and a few nuns. And then suddenly, we're gonna have a tile type grass E. Right? This is full career counseling going on. Bloodbound, yeah, bro. I'm doing everything. Look at that. Ooh. But if I hit the left, transports me to the top. Oh. If you ever go to the left, transports you back. But there's still quite a lot now going on. Let me fix that. So I'm gonna say any entity, but if entity is entity, or bro, you're serious. Thank you, sir. I really appreciate it. we got entity dot. So we can say the type of entity. How do I see this? For now, I'm just gonna say tile. For now, I'm gonna say tile, and tiles, and then I'm gonna say if tile dot type get type is equal to tile type dot tile type none, then we're gonna like return. So like break because none is basically air, so it doesn't matter. Like that's not real MCU. I'm still gonna call this entity. So now at least it's gonna fall through. It's gonna what? By the way, the none can be seen. Look at that. Look at that. The none can be seen. So if the entity dot get type is equal to type none, then break. Oh, we don't want to break. We just want to continue. We just want to. We're gonna just ignore. We're gonna ignore this entity, and then we're gonna move on to the next. Yeah. So you can't see it, but look at that. You can't see it because the none is like in front of you. Look at that. The none is in front of you, so you can't really see it. Let me um take all the tile types and then make them here. I'm clearing the depth buffer bit, and then now I'm gonna put the z behind. So for this the view mat is -1, right? But for these for our player, it's gonna be -0.5. You know, it's gonna be in front. Look at that. You see? Look, I was about to fall. Look at that. But then I can transport. So I can fall through this. I can jump. Look at that. Nice, right? That's amazing. I think that's pretty cool. I think that's pretty cool. I think that's pretty cool, bro. What we need to see now is completely fixed collisions. So let's fix the collisions. How we're going to fix the collisions? How are we going to fix the collisions? That's a pretty good question. That's a pretty good question. I applaud that question. I don't understand why I've messed up the height though. The height is bugging me. So where I'm doing the 0.75 or where I'm going to the player scale width, that's not scale, it's width. Let's see if that makes any difference. It's fat as hell, but it still can't move. That only scales its width, right? Hey, how are you? I'm good. How are you? A lot of people flowing in the stream. I did not expect this type of traffic to be coming in. I'm just building a simple platformer game right now. Just this is it. You know, it's not much. The collisions are a bit messed up, and yeah, I've just taken a free and open source asset. I'm also good, thanks. Wow. Do you have any programming experience, or how do you get to click? I'm from Pakistan, Karachi. So yeah, many people, at least at least every person that has come on the stream has asked that once, except for one. But most people, yeah, there are a lot of Pakistanis that join the stream. And I think that has its own thing benefits. I don't really see Pakistani streamers a lot. I think they should, you know. They really should. So, how do you mean to click on this stream? Are you interested in programming at all? Because I've been fighting bugs for the past 9 hours now, and the stream ended because my Ethernet cable got a bit loose. So it just looks like I've been streaming for what? For an hour. Yeah, so it's been more than 9 hours. But yeah, that's why I'm a bit tired too. I was very energetic at the start, and I'm not really used to this, right? So I'm just trying to cut up these streams and put them on YouTube, but these are starting to get a bit too big, you know. I'm gonna see what I can do, but yeah, that's basically how it's going, you know. I But anything you want to ask about anything, you know, I can start explaining it or just chatting too. That'll be fine. Right now, I'm trying to fix the collision, which means if this player is trying to hit a block, it should not go through it, and it also shouldn't go through the bottom. It shouldn't teleport when you go through underneath it. I know it should get max velocity. You can't just infinitely keep growing in speed. So that's all I'm doing. I'm doing it from scratch in OpenGL, no SDO, no nothing. So that's about it. Yeah. So that's basically it. Let me try and fix that. Basically, what I think now is that the time I've spent on Linux sysadministration in general, like I've spent quite a lot of time working with Linux. It's been like around 6 years, maybe. Yeah, 6 years, 5 years, at least 6 years. I could have, I could have spent that much better. You know, it's like even when I learned programming on my own, I didn't really have someone to guide me through it. I didn't know what resources to get out, so it took me a lot longer to figure out what to do, what not to do, and how to get where I am right now. Because I didn't really focus on any projects, and that led me to having a pretty empty CV. You know, I have a lot of skills, but not many projects to show for it. So you can't really trust a programmer who doesn't have many projects to show for. So I'm basically working on that, and I thought that streaming, since streaming gives me a bit of motivation to actually sit down and complete the project, I think it would be a good idea to do that. So yeah, let's see. Mm. Uh, where are you from? Dania Samas. Dania Samas. That doesn't sound like a local name. Sounds like Dania Samas. You know, maybe this is a play on the Japanese Sama. Unless that's true, that sounds like a somewhat South American name. Maybe. Don't check me on my geography. Uh, but yeah. So player dot set position Jalen Vec 2. I'm gonna check if our player's position. So what we're checking right now is player dot get position of Y. So we've tagged if a block is underneath us. We also want to check if the top part must be greater than its bottom. You can't just sit down here and then teleport to the top, which is what's happening right now. So its bottom would be its position minus, sorry, its position plus the tile size divided by 2. So it's position. I'm gonna get the player's position dot y. It's y position plus the top part, which is plus the player height divided by 2. So we're gonna minus that. Divide by 2. If that's greater than entity.get position y minus tile with height, that should be true. If that is greater than that, then it should teleport, but I'm still gonna add this. So get position of y minus player height divided by 2 minus player height divided by 2 must, if that's greater than entity dot get position dot y, entity dot get position y, and then we're gonna add to that half of our tile size, tile height half, tile height, and that should be it. Let's see if that works. Let's see if that works. Ooh. Oh, I've hit an and. That's what's happening. I think I want to hit an or here. So, or. Like that. Sir, can you guide me in choosing a character? Of course. Just ask away. Look at that. Look at that weird ass. I don't think I'm gonna do this right now. Of course, so hey, I can always guide you. Well, what's happening here? First you have to like figure out what's happening here. So the left wall, not now. Are you saying you can't guide me right now, or I can't guide you to the tree right now? But sometimes later when you're free. Of course. Anytime, bro. What's happening is its left wall, you know? We're just teleporting it to the top no matter. Sometimes later when you're free. So let's just see. If we're saying, look, if it's if the top part of its entity is this and all of this, then we're gonna set this position. However, if only its left wall, both of these should be true. So the x plus player width divided by 2, x plus player width divided by 2, x plus player width divided by 2 should be greater than any red position x minus tau width divided by 2. And same with this. And same with this. So if an object is here, and then it touches this from this side, what happens? It says, yeah, that side is definitely greater than that side, and that side is definitely greater than that side. So all of the conditions match, and that side is definitely greater than that side. What we want instead is to check, is the left side of this greater than less than the left side of this, than the right side of this. What we're trying to say is the distance between this and this can be greater than a tile size, you know? So that's what we're trying to say. We're not trying to say all this. We're saying that the distance between this if my brain's not working out of cheat. Come on, bro. I need some basic collision detection. You just can't give it to me, bro. Okay. Imagine two rectangles. So the first rectangle's coordinate is this, the second rectangle's coordinate is this. Since both conditions are true for both axes, the rectangle is colliding. So basically what needs to happen, I remember now, is that the min x1 is less than or equal to max x2. So basically this side is greater than that side, and then max is less than x 1 and max x1 is greater than or equal to min x2. Max x1, so this right side, is greater than or equal to min x2. So if both of those are happening, that's wrong. The AI just juked me. Bro, give me just the basic. Okay, here it is. Rectangle 1.x is less than rectangle 2.x plus rectangle 2.width. What? I don't know. Oh my god, my internet cable was. My internet cable really just got loose again. Did the stream start again? Is the stream continuing? Did it just break away? That's crazy. Oh, my Ethernet cable fell loose again. Anyways, that's sad. What algorithm did we find here? We found a 2D collision detection here. Its x must be less than its left side must be less than its right side, and its right side must be greater than its left side. The right side must be greater than its left side, and its left side must be less than its left side. So let me just try that. So let's see. The rect1.x. So we're gonna replace rect1. Replace rect1 with player.get position dot yeah, player.get position, and then we're gonna get rect2, and that entity dot get position. But if you see any width, so entity yeah. So sorry for losing commentary there, but we're going to player.get position width. So that's just player width. So that's adding player width divided by 2. So player width divided by 2. And that is actually subtracting player width divided by 2. That's less than entry.get position plus its width, which just means plus its tile width divided by 2. And entry.get position x is just minus tile width divided by 2. Then player.get position y means that we're subtracting player width divided by 2. And once we're adding a height, that just means that we're adding player height divided by 2. And entry.get position dot x minus tau. So entry.get position dot y plus that, which just means plus tile height and entry dot get position dot y minus tau height. Okay, when any of these is true, I'm going to print out collision. So yeah, it fell through. It felt the collision for some time and then stopped. Isn't that crazy? So we get the collision. Now what do we do based on this collision? Now we're gonna check if there is collision. We know that two of these things are collided. Where do we want to set them to proof? So if their velocity yeah, so what we're instead doing, I remember what I'm doing. I want to set velocity to this instead of this. I want to set velocity to this. Instead of adding it to that, I want to set that velocity. Now what happens now is instead of doing all of this, I can just check if player dot get velocity, if it's the velocity is less than 0, then I'm probably interacting with, I'm moving left. If the velocity is left, yeah, which means I'm moving left, I must be interacting with the left wall. There's just no other thing. So let's say I'm falling off a cliff between these two, and I'm moving left constantly, but then I collide. If I collide, I've just collided with this. So if player.getVelocity.x is less than 0.0f, then we're saying that we need to say player.getVelocity player.setVelocity to GLM vec2 0.0f, and then we can get player.getVelocity.x or get y for that. And same with here. So else if we said, oh, that's greater than 0, so we're just gonna set it to 0 again. Doesn't matter, which means that it's either less than or 0 or greater than 0. We're just gonna set that to 0. Else if I'm gonna reset that on my y, I'm gonna set that on my y. Then I can simply x and then 0.0f here. I don't know if this will work. Let's just see. Ooh. What's happened here? Oh, it's trying to set it to like it was in mud, bro. We're gonna add it after we're done calculating the velocity. Just like that. Okay, I can move left or right. If I switch that, set velocity to whatever velocity at x at. So we're colliding, and if player.getVelocity.x is less than or greater than 0, no, and we hit the wall. Bro. Or what is this? Clear.give velocity. This is left side plus right side of wall. Left side of flare plus right side of wall. Let's do this again. Left side of flare. Left side of flare. And right side of wall. So that should be less than that. And then the right side should be less than the right side should be less than the left side. Should be greater than the left side. Should be inside. And then same with the y. What we're saying, if that situation is true, then we gotta set the velocity to 0, bro. Let's try and maybe move this. Try and move this about. No, so what I'm saying is we're gonna take input at the end. So let's forget this input thing. Try and add that, and then add that, and then try and check if we're trying to do anything goofy. No, never mind. That doesn't make any sense. Okay, we're gonna check if collisions happen. So all 4 of those must be true for a collision to happen. So inside, where do we want to teleport it? How do I teleport it? We want to teleport collision causing teleport. Go to the bottom of box. Yeah, how do I define trigger and then the detection? Collision resolution. For everything that's colliding with the parent figure of the closest one. Assuming you have the record of sprite, you can see which corners and sides are over that might be overkill, but I can do an additional pass regular the distance of each of the point to the center of the square sprite. Short distance of the steps statements. Once that is handled, I check the collision again to see if everything is colliding. I have custom collision boxes, part of the box that respond very differently. So collision resolution. To where they're touching but no longer intersecting while imparting a bounce impulse to their velocities. Can range from very simple crude to complex real life art. Accurate for a simple version, you can treat all things as having equal mass, find the normal intersection, the vector between the two objects, and use it to bounce the velocity. So instead of setting the velocities, we're going to set the velocity to the negative of the flare velocity. So this is going to flip it. Okay, let me think this through. So we have this left and this right. And so now we know 2 things are colliding. Right? So first we say, oh, just collided. But we want to see where should it teleport here. We can take its distances and then sort them. What can we do? Was good on all this. Was applied friction. Here we go. We have a collider. solve only for x-axis. If object 1 is moving right, then position 2 at x minus. Yeah, so if it was moving right, or if it was moving left, that's how we do it, right? If we were moving right, so instead of setting the velocity to 0 on the x, we can try and set the position to just the we can just try and set the position elsewhere. So else if like that. Get position y. Clear dot get velocity x. Clear dot get velocity x is greater than 0.0. So we can set the position to the entity. We can say if we're moving left, we want to take entity dot get position dot x plus where or we could be moving left while we're falling, we could also have to check for is falling. So we can plus tile height divided by 2. Entity dot get position dot x plus tile width divided by 2. And if it's greater than 0, then we can subtract it. We're doing this. Okay. And now, all that we want to do now is take its y, take its height divided by 2. If its y is less than 0.05, we're going to get its position x. I'm going to save it. And then we're going to get its position at y. We're going to get its position at y. And then we're going to subtract our tile height from that. We're going to subtract our we can subtract our tile height from that because we're moving upwards, so we actually have to do the opposite. But once we're moving downward, we're greater than 0.05. And 0, 0 is in the top left. If it's greater, it's moving downward. If it's greater, it's moving downward. If it's greater, it's moving downward, which means we need to check entry dot get position dot x plus, so we can plus this. No, what are we doing? Subtracting it. We want to subtract it. We can subtract it now. I don't know if this will work. I don't think so. Yeah, what the hell is happening? What the hell is happening? So we can add the position. We can add the position and then we can set its position again. Look at that. What the hell? It should push that box just enough to be it's right. But that's only because it's colliding it right side with your left. Okay, I'm getting really sleepy and I can't think straight. It's been basically 10 hours, maybe 11. Yeah, more than that. I'm gonna upload this on this YouTube channel. I'm gonna edit it down, make a clickbaity thumbnail and some title. It's not really clickbaity because it's kind of true. That's basically it. That's basically it. Isn't that cool? I think that's pretty cool. I got a lot of tatters today. That was interesting. And yeah, that's cool. That's cool. That's cool. I like it. That's cool. Yeah, I'm ending the stream. It's been way too long. Yeah, 10 hours and 13 minutes. That took way too long. But at least I have quite some to show for it, you know? I have what to show for it. I have the crappy, almost platformer. Whatever this is. What the hell is going on? But yeah. Let's see how fast it is. Okay, opens instantly. Look at performance of that baby. But yeah. Thanks for everyone who joined. Thanks for adding. And I hope you enjoyed the stream. I enjoyed making it. I enjoyed programming this project. And I really enjoyed streaming. So if you want to stream more of this content, then head over to my YouTube channel or Twitch and let's see what we can do. And I think I will obviously move on to more complicated projects, but slowly, you know, slowly, eventually. Yeah, thank you. Goodbye.